അയ്യോ അവൻ ഇത്ര വലിയ ആളായിട്ട് അവൻ അറിഞ്ഞില്ല കേട്ടോ ദാസ. ഭയങ്കര
அவனுக்கு தெரியும் அவன் இதை பிளைட்டே ஓட்டுறான் சும்மா
आता 3 सेशन आहेत, मग 6:30 ते 8:30.
त्यांनी लाठीचार्ज केलेला. अहमदाबादमध्ये पोलिसांनी 6 लाठीचार्ज केला. पुढे तालुक्यातील पालक अधिकारी
Good afternoon, ma'am.
Sir, can you check your PPT? Voice and
Yes, ma'am.
Okay, sir. Okay. So, sir, let's start.
Yes, ma'am. Thank you.
Working is working.
So, good afternoon, everyone.
Sir, introduce yourself. Sir, 1 minute.
Good afternoon, everyone.
Sir,
Yes,
just,
yes.
just 1 minute.
Yes, ma'am.
Yes, just 1 minute, sir.
Yes, ma'am.
Okay, okay. Darren, Miss? Darren, Miss?
Yes, ma'am.
Am I audible?
Yes, ma'am.
Okay, so let's start. Good afternoon, everyone. I'm Asha Devasikuti, Assistant Professor, Department of Civil Engineering, and I will be the host for this session of today's program. On behalf of this organizing team, I extend a warm welcome to all the participants. We now move on to the session, which will be handled by Dr. Madhyalakan Sumesh. It is our privilege to have him with us today also. And I take this opportunity to warmly welcome you, sir. Introduction about Madhyalakan Sumesh. Dr. Madhyalakan Sumesh is currently serving as an assistant professor in the Department of Civil Engineering, Dayananda Sagar College of Engineering, Bangalore. He previously worked as a postdoctoral research fellow in the Department of Civil Engineering, University of Malaya, Kuala Lumpur, Malaysia. Prior to this, he served as associate professor and head of Department of Civil Engineering at KR College of Engineering, Tiruchirappalli, India. He earned his PhD in Materials and Structural Engineering from University of Malaya, which is QS ranking 58. He completed his MTech in Geotechnical Engineering from IIT Guwahati and obtained his BE in Civil Engineering from Anna University. Dr. Sumesh has extensive academic and research experience and has served at reputed institutions including NIT Trichy, Karpagam University, and Karunya University, Coimbatore. His research contributions include publications in premium journals such as ASE, Journal of Building Engineering, and Construction and Building Materials, with 10 Web of Science indexed and 5 Scopus interest journals articles. He also holds 4 patents, including granted patents in Malaysia and the UK. He is an active reviewer and editorial board member of 4 reputed international journals published by Elsewhere's, Taylor and Francis, and Sprinters, among others. With this brief introduction, I'm confident that Dr. Sumesh sir is the perfect person to handle today's session, and all participants will gain valuable insights and knowledge from his talk. Before we begin, I kindly request all participants to turn on your camera for group photograph. Okay, thank you. Now I request all participants to mute your microphones and turn off your cameras to ensure a smooth session. Sir, I now invite you to begin the session. Over to you. Thank you. Thank you all.
Thank you, ma'am. Good afternoon, everyone. It's a great pleasure to be here today again for the sessions FTP on sixth day. So I thank once again. I would like to thank our management of IES College of Engineering, Thrissur, and also the Department of Civil Engineering and HOD, and the FTP coordinators for organizing this FTP. And the wonderful arrangement of this. I'm going to share some of the insights today on the topic of enhancing urban disaster resilience through smart city technologies. So here, some of the concepts we'll see here in the introduction, and some insights about the disaster risk and urban resilience in smart cities, and urban disaster resilience impact and role of smart city technologies, and some of the emerging and cutting edge technology and the tools, and some case studies. So these are the content of the FTP sessions. Let's move on to the introduction part. So in today's world, we see here the rapid urbanization, as we discussed earlier. So the development of smart cities are transforming how societies
Okay, understood.
live, work, and grow. So while these developments are improved efficiency and connectivity and give quality of life, so they also introduce new and complex disasters as well as. So as already we know that climate change and infrastructure stress, population density, and technological dependencies, so all these things, if we see here, make urban areas increasingly vulnerable and vulnerable to both natural and human-made hazards. So therefore, understanding the disaster risk and strengthening our urban resilience have become one of the critical priorities nowadays. So building resilient smart cities require one of the main concepts like advanced technology. So, but also inclusive planning and our supports from the authority, robust governance also very much important for preparedness and other recovery during these disasters. So this topic of the FTP sessions try to highlight some of the integrated management of a disaster risk reduction, how it can be implemented in urban developed area to have a sustainable smart city concepts for the future. Okay. Next, let's move on to the disaster risk resilience in the era of a rapid urbanization and smart cities. How much it can be significant and how it is significant in this rapid urbanization on the disaster risk reduction and management. Let's see here. If we see here, we all know, we all agree and know that the urban growth supports economic developments. So as already we know that. So even though it also significantly increases vulnerability. to the disasters in the particular systems. So the problem is the expansion of informal settlements happening in the particular area, and also inadequate infrastructure systems, and also poor land use plannings and encroachments. If you see the figure, so most of the encroachments and poor land use planning and other disaster prone can be occurred in the full floodplains and the coastal areas, which is exposure to the urban populations to higher risk in the urban area mainly. So this one leads to higher risk in the particular urban zones. So the high population intensity means even small scale hazards can cause widespread damages. We know that's already. So surely that will disturb the essential services also. So ultimately that will lead to sustainable economical and human losses. So that is one of the important thing in rapid urbanization increases in towards disaster risk. So next one is the climate change effect. How the impact of climate change on urban disasters. We see here the climate change has identified one of the severity. So it has both frequency, severity, as well as the natural disasters occurring during the cities at the time of cities. So rising global temperatures is one of the main thing under impact climate change. So that can contribute to the extreme heat waves and also impact some of the stresses, particularly on the public health and also some of the energy supplies and all during the disaster and events. So the changes and also the changes in the precipitation patterns and rainfall patterns that also increases the challenges, and it will give some of the critical uh, potential effects on the urban flooding and other effects. Although the earthquakes are not caused by climate changes, the earthquake we know that earthquake not due to the climate change, but we know that but some of the climate induced urban areas and poor construction practices, as discussed, that is very much important. That can be given was the impact, it will make the impact very worst case. So together all these things, these factors make cities increasingly disaster prone zone, and also it makes the cities harder to protect using the conventional methods like conventional and whatever we are using. So that without any latest technologies, conventional methods cannot be helpful for rectify this kind of harder situations. So next one, go to the limitations of traditional disasters management systems. Like conventional systems, as we discussed, are largely reactive, but it's not proactive. So at the same time, focusing on emergency responses and the post-disaster relief rather than preventive and preparedness. So preventive and preparedness we may not be getting from the conventional management activities. So for example, in case if you see here, any hazards or any disaster happening in particularly on complex urban environment, if you see, so the system often rely on delayed data. Some of the times we get the data delay, and also manual coordinations one of the main problem, and there are so many problems related to the conventional systems. So ultimately, as a result, they struggle to cope with this kind of preventive measures. So that is happening. So there is one of the limitations in the conventional method of traditional method of management systems. For this, the lack of early warning mechanisms is very much important. So real-time monitoring also very much important, and also the community level engagement that will be reduces due to this kind of conventional systems. The lack of effectiveness is much more in this kind of conventional systems. So next let's move on to the role of smart city technologies. So if you see here, the smart city technologies, it offers a transformative shift. So transformative technology towards predictive and real-time and adaptive disaster resilience. That is very much important technology here. So if you see some of the tools like IoT sensors mentioned here, you see here IoT sensors, satellite imagery, and it will be very much useful for smart transportation, smart energy maintenance, smart building, and even the healthcare and smart home, smart building technologies. So all these things are enable continuous monitoring of environmental conditions and infrastructure and also health and all. Okay. And next, some of the things like predictive models. So that can be very much useful for forecast our floods and heat waves and even cyclone impacts, and all these things can be predicted, and it can be analyzed in the predictive models by using some of the IoT tools and sensors. So that can allow the authorities and engineers and even citizens, it will be enable them to take preventive action immediately. So this one smart technology tools enable our productive resilience as compared to the conventional systems. So the main thing, so ultimately the rapid urban extraordinary efforts that will make the situation worse during this disaster risks. So moreover, the traditional systems that can be no longer sufficient to address these challenges. So we know already. So ultimately, smart city technologies provide a proactive and integrated approach. So that we have to adopt. So it is very much essential for sustainable urban development and a long-term human safety. So let's move to the urban disaster resilience. So what is urban disaster resilience? So urban disaster resilience refers to a cities or urban area. So how the ability to anticipate the disasters, how it can absorb their impacts and recover quickly if there is any incidents or disaster happens, how it can recover and how it can transform the systems to reduce future risks. All these things related to urban disaster resilience. So here, anticipated disasters, absorb impact, adopt and recover the systems. So transform systems to reduce future risks. So all these things are combined in the disaster resilience. So the first one is anticipated disasters. A resilient city doesn't wait for disasters to strike or any event to occur in the particular time or situation or any systems. So it uses only technology or data planning to predict the potential hazards. So early warning systems are coming under anticipated disasters. So that's called anticipated disaster systems. The next one is absorb impacts. So moreover, a strong infrastructure emergency response plans and the community awareness programs, so that all reduces the immediate damages. So absorb impact is very much important. So when a disaster, any event occurs, any event hits in a particular urban zone, any event occurs, so that resilient cities, if the cities resilient cities, that must be designed to withstand shocks, any vibrations or damages. So absorb impact is very much important. So next one, adopt and recover quickly from the systems. So adapt and recover quickly from the system is, so it isn't just about rebuilding how it was lost, but at the same time how the system is restoring essential services like public health services, how the life can be getting back. So all these things to normal to as quickly as possible. That's called adapt and recover quickly. Next one is transform systems. Truly resilient systems, that means it learns from the disaster in their history in the particular city or any urban area, how it upgrades its infrastructure and improves the urban planning and strengthen the governance and the authority to reduce the vulnerability in the future. So that is coming under transform systems to reduce the future risk. So transform system is very important for the urban resilience here. So next move on to the smart city concept. So what is smart city concept? So here, if you see the figure, the smart city concept is just it uses a technology, sensor, and the data to manage resources, improve city services and urban development, and also enhances the citizens' quality of life. So that is simply the concept of a smart city. So here, if you see some of the key features in the smart city concept is coming under smart infrastructure, smart transportation, smart energy, and disaster preparedness and citizen engagement. So all these key features combined in the smart city concepts. So what is smart infrastructure? So it is one of the resilient and sustainable building and utilities which is attached with the infrastructure. Next one, smart transportation. So the traffic management and traffic monitoring and the sufficient public transport and how it can reduces the congestions, all these things related to smart transportation systems coming under smart city concept. Next one is smart energy. So how it uses the renewable energy and the efficient electricity management, energy management, how it reduces the fuel and fossil fuels gases, how it can be managed, how the CO2 can be managed. All these things coming under smart energy technology. Next one, disaster preparedness. So this one, early warning systems and better emergency response. How the emergency response can be immediately transferred from one stage to another stage during the disaster. So this is coming under disaster preparedness. The next one is citizen engagement. So this one, there are many apps and platforms that can be available, that can be developed to report particular problems and access some of the services easily during the disasters. So that will be coming under citizens engagement. So all these key features are combinedly called as smart city concepts. So the main benefits from the smart city concept is how it makes the cities safe and how it makes the city more resilient. So that is important in this smart city concept, one of the benefits. And also it reduces the environmental impact if there is any disaster and anything happens. So smart city concept will be helpful for reducing the environmental impact, and also it improves daily life and convenience for the citizens. So if you say the smart city concept is continuously improving the technology and the sustainability, and also planning to create a better urban life. So next, let's move on to the role of smart city technologies. So what are all the different roles coming under smart city technologies to uh, give more enhance the resilience of the particular urban area? So here if we see the rapid urbanization, already we know that it is one of the things has brought incredible opportunities and economic growth and also innovation and so many improvements in the quality of life. But however, it has also been it's also been created some of the challenges like traffic congestions, pollutions, and energy demand, and even vulnerability to the disasters. So all these things, one of the negative impact of urbanizations. So this is one of the smart city technologies. If you see here, so this one plays a very crucial role. So the technology uses some of the digital tools like data analytics and modern communication systems tools. So this one make the systems more efficient and sustainable as well as more resilient during the disaster time. So the main goal of this smart technology is minimize the disaster impact while ensuring continuity of essential services without affecting any essential services and other facilities. So how the systems can be minimize the impact. So that is the main role of smart city technologies. So the some of the cutting edge technology, if you see here, IoT sensors, satellites, this one mainly used for data collection. So data collection can be done by IoT sensors and the satellites. So another one, AI, big data, so cloud, all these technology and tools can be used for data processing. So IoT sensors and satellites will receive the data collections, and then the data will be processed in the AI and the big data. And the decisions and support systems can be controlled by command and control centers. The next one. So after the command and support systems, that will go to the action and response. So the action and response can be managed by emergency services and alerts. So emergency services and alerts, which is very much important. So that is the action response to the particular community or particular get the emergency rescue and all. So next one is last one is feedback. So this feedback is coming under recovery and learning. So after the action response received from the emergency alerts, so we'll go for the recovery and learning from the feedback. So these are the major things and one of the cutting edge technologies followed in the disaster resilience. Next, let's move on to the role of smart city in terms of IoT technology. We see here, so smart technologies already we discussed. It allows for real-time monitoring and the management of a city infrastructure. So IoT, if you see here, the IoT on road infrastructure, roads, even the bridges, and also water systems, so that will detect the wear and tear and even the leakages or all the problems can be identified even when we use IoT systems in for monitoring flood, even seismics and weather monitoring. All these things can be done by IoT sensors. Smart grids, another concept which is very much helpful for managing the electricity, even all the infrastructure, the electricity management, and how it is efficiently used, how it can be reduced, how the energy can be reduced, the wastage and preventive blackouts. All these things can be controlled by IoT and smart grids. So the intelligent traffic systems, if we see here, so that will reduces the congestions and saving the fuels and the efficiency, improve the efficiency and also improve commute times. So these are the main benefits when we use this IoT and related smart grid systems in the transportations. So by making infrastructure responsible and data driven, so the cities become safer and more reliable for the residents when we use this kind of concepts. So next, let's move on to the role of smart city technology when we adopt improving disaster management and resilience concept. So here, this is one of the most important applications of smart technology in the urban resilience area. So here, the sensors and early warning systems can predict flood flood in a particular urban area, and also if there is any storms or storm water flow or heat waves happens in the particular this one, so this will be giving the early warning systems by using the sensors. And also as discussed, AI and big data, so that also very much important for collecting the data. So that data collection is also very much useful for analyzing the particular urban patterns to anticipate how the risk and in the particular urban zone. So will be helpful for early warning systems and also the real-time communication networks. So that is very much useful, and it is very much helpful for coordinating the emergency services and during the disaster, how the evacuation systems, how the evacuation efforts efficiently can be taken. So that is controlled by real-time communication systems and networks. So unlike traditional and conventional methods, so smart technology by using all these concept sensors, AI in big data, real-time communications. So all these things enable the cities to anticipate, observe, respond, and recover quickly from the disasters. So next, let's move on to the another role of smart city technologies by using promoting sustainable urban development. So here, the smart water management, if we see here, the figure, the smart water management, so that reduces the wastage and ensures clean water supply. So another one is air quality, so waste management, so water management. All these things are very much important, and it is completely composed by this kind of urban city technologies. So smart waste management, so it is very much useful for ensuring clean water supply. So another one is air quality sensor can be adopted, and this will be very much useful for monitoring the pollution, how the air quality according to the policy and guidance that can be assured, and also waste management systems. So this one very much useful for optimizing the collection of wastage in the particular urban zone, and and also it is controlling the recycling process of the waste management systems. So all these concepts ensures the cities cannot only grow but grow responsibly and also reducing the ecological footprint. So this one very much important concept. So next one, let's move on to the another role of smart city technologies by using enhancing citizen services and quality of life. So here, if we see, smart technologies make life easier for citizens, as we discussed. So here, one of the important tool is mobile apps. So another one, digital platforms and smart healthcare and telemedicine systems. So these are very much important, which is composed in the smart technologies. So to make our life easier during the any disasters, any events. It's real-time public transport updates. So this is available nowadays, and also it will give us some utility bills, even the service checklists. All these things can be done by using mobile apps. So most of the things already established through mobile apps. Next one is digital platform. So digital platform enable direct citizen feedback. So this one will be enable and very much useful at the time of action and remedial time. So direct citizen feedback also controlled by some of the digital platforms, which is coming under the authority, under the governance. So next one is smart healthcare and telemedicine systems. So this one improves one of the medical services, like how the access can be easily we can perform during the medical services at the time of any disasters. So smart healthcare system is very much useful. So here, if you see the figure, the mobile app and real-time updates, and the smartphone showing a city transport app, even the bus and the train updates, even the utility bills, all the service requests we can update when we travel, or even if we sit at home. So all these things can be accessed by using the mobile app. Transport, utilities, all the notifications, we will get up to date according to the and this one requirement. And also the digital platforms for the digital platform for the citizen feedback. So this one also very much useful for interacting with a particular city portal. Even we can use laptop or any mobile or common systems to access this digital platform. The last one is smart healthcare systems. So this one, even some of the times the video call or even a smartphone, that is very much useful for connecting with the doctor or any consulting with the patient, communication between patient and doctor. So this one coming under smart healthcare and telemedicine systems, as I told before. So this one shows one of the improved access in smart healthcare systems. So overall, by connecting citizens and city authorities, so smart technology, so that enable and foster a responsive and inclusive urban environment. So then it will become a more efficient. Even though if we have all these facilities, so the technology foster a responsive and inclusive urban environment. So that we need to keep in mind to get a better and more efficient systems. So next, let's move on to the emerging technologies. So some of the emerging technologies related to disaster risk management is remote sensing, post-disaster damage assessment, and climate risk visualization. You see the figure. So the main thing is here is geospatial technology and satellite technology. So this one already we have been discussing in many of the events during the disaster. So geospatial technology is one of the technology that is very much useful for getting information through the mapping and analyzing the earth. So it uses data about locations, distance, and landscape to help the urban and cities governments they even make better decisions during or before the event or any disasters. So that is geospatial technology, and even it is very much useful for weather forecast predictions and storms, and all those things can be predicted by using the geospatial technology. Next one is a satellite technology by using IoT data and processing systems. So if you see the figure, the satellite technology, this is very much useful for collecting data from space. So they capture images and monitor the weather, and even tracking ships, even planes, and even help in disaster management time. Also, it is very much useful for tracking the system by using GS processing, by using satellite technology and images. For example, if you see here, the satellites can detect even floods, forecast forest fires and and also the crop and the vegetation management and monitoring. This will very much helpful for other authorities for the quick response during and the time of any disaster time. So these geospatial and satellite technology applications have been in everyday life, our life. So navigating and mapping. So that is what we are using by using GPS and the mapping app. So that rely on a satellite to give accurate directions. So that is very much useful for navigation and the mapping systems. On disaster management, disaster and disaster risk management, the early warning of floods, hurricanes, and earthquakes come under satellite monitoring. So that is also will be getting in the gist processing as per the satellite IoT data. And environmental monitoring. On environmental monitoring, tracking deforestation, the vegetations, air quality, and water resources, also controlled by environmental monitoring under satellite IoT data. And the next one is urban. If you see here, urban planning. So cities uses geospatial data to plan roads, even the roads, highways, transportation systems, and other utilities related to infrastructure, even public facility, how efficiently can be planned. So that is coming under urban planning. So that is also composed with geospatial data and satellite IoT data to control and monitoring the process. So ultimately, the geospatial as well as satellite technology connect us to contemporary world, the current technological world. So they make cities smarter and protect the environment and keep us safe. So in the daily commute to disaster management, these technology are quietly shaping more and more informed world. So next, go to some of the case studies. So if we see here some of the case studies like earthquake early warning systems. So in Japan, some of the technologies they use like advanced IoT sensors and seismometers. They use IoT sensors and AI-based prediction systems. So these all completely working together to inform early warning systems to predict and to get the resilience against the any disasters happen. So in Japan, they use this kind of sensors and AI-based tools to predict the systems. So how it works means the sensor detects seismic activity if there is any uh, urban area affecting or predicting this kind of events. The real-time activity can be the data can be analyzed by using the sensors and which predict the intensity, how much intensity, and also how it and the earthquake reaches. All these things can be predicted, and the alerts are sent via even any public platform or app, anything or any public platform or even an individual app or to the citizens that can be done within seconds to the to communicate the particular citizens. So that can be done by using these sensors. So they have done it in Japan by using AI and IoT. The main impact is it allows people to take immediate precautions, like automatically we can stop the vehicle or any trains or any transport system can be stopped, and even elevator or any industrial machineries, all this can be immediately stopped once we get the alarm or any immediate warning systems. And also it will reduce the casualties and any property damages and other effects can be minimized even we get the early warning systems by using this kind of IoT AI-based seismometer sensors. So in Japan, one of the case studies just we have discussed. Another one is in Singapore. So some studies shows that smart flood monitoring and the drainage control. So smart flood monitoring drainage control using IoT sensors in drains to check water levels, how the water level rises and how the water level rises, and as well as the rainfall, how the rainfall precipitation patterns, all these things can be predictive analytics and modeling can be done by using this IoT sensors. They have done it in Singapore, that project, Smart Flood Monitoring Drainage Control Project. So the main impact of this technology is that minimizes the urban flooding. So minimizes the urban flooding and protects the infrastructure and also ensures faster response to flood and stormwater challenges. So these things very much important. So how it works, the sensor is, so the sensors continuously monitor will be monitor how the rainfall intensity, rainfall patterns are monitored and analyzed by using the IoT sensors. And also automated pumps and sluice gates are activated directly. How we get the mobile app or any social platforms getting the early warning. Similarly, the IoT sensors during the flooding time or any the automated pumping systems sluice gets get activated by getting the early warning systems, and alerts are sent to the particular residents or even any authorities in the particular area, the urban area, any vulnerable areas. So these are advanced technology. So this is the main concept in this IoT sensors they used for monitoring the drains, water levels, and the rainfall and floods. So the real-time monitoring and automated control systems, so that are these are all very much helpful for cities adapt to climate related hazards efficiently. So, however, IoT sensors connected buildings by monitoring real-time conditions like temperature in the buildings, even occupancy, air quality, and energy usage in the buildings. So, all these data can be monitored. The energy in the buildings, how much energy we use, how much energy required for the buildings, and the lighting systems, ventilations. That's called HVAC systems, heating, ventilation, and air conditioning systems. How the lighting, security, maintenance for smart operations, all these things can be controlled and connected by using the IoT sensors in the buildings. Okay. So next, the major important thing is the key important thing, the key benefits from the IoT sensors in the building is, so temperature and humidity can be monitored continuously by using the HVAC systems. So that will optimize the comfortness required, particularly during the daytime or night time. So how much the comfort is required, so that will be controlled and detect the and it will detect and give the monitoring systems and the alarm systems, and also the detect air quality sensors. So air quality sensors, temperature sensors, humidity sensors, all these things can be attached with the buildings. So this will give you the air quality management, and that will monitor the pollutants in the air, and also it will give the ventilation systems quality, how healthier our indoor environments, temperature, air quality, all these things will be monitored, and it will give the early warning systems, and also the light sensors available, and how the leakages happens in the buildings. So leakage also monitor can be monitored. So light sensor also monitored by using adjusting the artificial lighting based systems can be connected with a sensor in the building along with the natural light availability. So that is detect and give the warning how much we how much the usage, actual usage and consumptions, and how much the efficiency, how much energy differences, all these things can be controlled. Water leakages, energy meters, all these things are very much important in the sensors connected with the building IoT. So the data collections is the first step. Next, connectivity, then processing can be done by software. Some of the softwares can be used for analyzing the data, and then that will give you the alerts and preventive measures directly to particular individual or residents or any authority. So that will be transformed after the data collection, uh, processing, and then some of the insights will be immediately transferred to the particular society or even authority or individual. So the main benefits is energy efficiency and enhanced comfort and health will we can ensure, and also predictive maintenance can be identified and immediately that can be followed immediately, and also improved security. So all these things are benefits from this building IoT. Next, let's move on to the some of the this one, the and the summary. So here the smart city technologies transform. We see here the smart city technology transform technology is reactive, but smart technology, city technologies will be like a proactive technology. So this technology plus the authority, governance, and community, so that will combine together and it can achieve urban resilience. So that is very much important for our urban resilience, how we can manage any disasters or any other events. So technology plus the authority, support and power, governance plus community. So that will give us to achieve our urban resilience. So moreover, aligning our innovations, whatever we do, IoT, sensors, even all our research and innovations, along with our sustainable development goals, SDGs, that can be ensure our sustainable, safe and inclusive smart cities in a better way. So the modern tools like smart city technologies, as we discussed, that can be play a major role in urban disaster resilience, like sensors we discussed, AI, and the data analytics, and even real-time communication systems. So all these things allow cities and even any urban areas to predict, monitor any responses, any how it can be efficiently control the hazards, how we can make safer and smarter in the current contemporary systems. So that is very much important. These things are very much important under smart city technologies by using modern tools. So with these things, concluding that building urban disaster resilience is not just the responsibility of just authorities. It's a shared responsibility. So simply we can say that it's a shared responsibility of the citizens too. So the communities, planners, even engineers, architecture, even all the citizens. So all we have an essential role to play in this process of enhancing the disaster resilience by smart cities, uh, enhancing the disaster resilience. So by participating, by adopting all these things, so we can really we can make definitely we'll have a efficient disaster risk management. So most important transforming our cities is we can ensure that our urban spaces are not only thriving centers of growing growth, but also safe, resilient, and sustainable for the future. So that we have to keep in mind. So by anticipating risk, absorbing shocks, any damages during the event or disasters, how we are recovering from the, how we are efficiently recovering from the disasters. So these are all most importantly transforming our cities. So that thing we have to keep in mind. Cities. So that will give us better cities tomorrow. So thank you. Thank you.
Thank you very much, sir.
Thank you.
We will now open floor for interaction and questions. Participants may post their questions in the chat box, or they can raise their hand, or they can, and they will. I will read out the question to the resource person. Sir, may I read the question?
Yes, ma'am.
Okay. How can smart cities strengthen resilience against flood, earthquake, and cyclones?
Some of the smart softwares already we discussed some key softwares and tools that can be used for analyzing and some of the satellite data. So IoT sensors. So all these things can be very much useful for predicting the flood in the particular area. So that is very much useful. Some of the softwares like advanced technological tool, Geo AI and uh, GS based software is available to control the to control and monitoring and getting the land use prediction, how the environmental modeling can be analyzed. So that is very much useful for predicting the event, particular disaster event.
Okay, thank you, sir. Next question. What challenges exist in integrating legacy urban infrastructure with smart technologies?
Repeat, ma'am.
What challenges exist in integrating legacy urban infrastructure with smart technologies?
So AI driven system. So that is one of the main thing for the disaster response and disaster monitoring. This one can be that we need to integrate and adopt, and also that will enable the climate adaptive and smart city issues and any disaster event. So all these things can be AI driven autonomous disaster response is very much important, and and also integration of some of the latest tool as we discussed directions based on the research and smart resilience, inclusive concepts can be adopted.
Okay. Okay, sir, thank you. Next question. What lessons can be learned from failures or limitations of smart city projects?
Repeat, ma'am.
What lessons can be learned from failures or limitations of smart city projects? Sir, is it audible?
And repeat, ma'am.
Okay. What lessons can be learned from failures or limitations of smart city projects?
If there is any failure or any
Yes, limitations
this
or
one
smart city projects.
limitations.
Yes, yes.
So, so the keys already discussed like tools, softwares, and even and the AI and machine learning concepts. So that is very much useful for analyzing, modeling, predicting data, even all the infrastructures like building, roads, transport, including GIS systems. So even satellite data, images, and analyzing. So all these things can be integrated part of our disaster resilience concept. So if there is uh, any miscommunication or any this one data uh, interpreted things can be happen. So that can be identified by using continuous research and disaster predictions by using our infrastructure analysis. So physical modeling and even our urban planning and disaster predictions can be controlled.
Okay, thank you, sir. Next participant asking, any free software is there, and what are the names of that free software?
Mostly we have access to QGIS in most of our places. We have a QGIS. It's one of the open source GIS software. It's free and open source. So that is really very much useful for getting the data, satellite images, and so that is very much important for predicting and analyzing the uh, infrastructure data. Another one is Geo AI also available, but we can have limited access. So that is one of the important AI just connected software, Geo AI. So Geo AI also AI powered spatial modeling will get like output. So this is very much useful for analyzing our satellite images in the particular vulnerability area, the urban areas or any particular geospatial insights if we want in particular in area. So this is very much useful. AI just based software, Geo AI and QGIS and even ArcGIS also available. So this is also one of the open source software for analyzing and forecast how the land use changes, environmental risk, and even urban growth patterns, vegetations. So all these things will coming in 3D modeling. So ArcGIS and GeoAI, QGIS, these kind of softwares are very much useful.
Okay, thank you, sir. The next question, what is the role of ITS in smart city?
Role of
Sir, I just repeating.
yes,
Role of ITS in smart city.
IoT, ma'am.
It is
IT.
ITS. Maybe IoT. Maybe they are
So Internet of Things, IoT.
IoT. Okay, sir.
So IoT sensors and this one we already discussed in our presentations. So building IoT. So IoT integrated building system is very much important to control our HVAC systems. So heating, ventilation, and air conditioning systems. How the lightings, how the security of the buildings, how we can maintain our smart buildings. So that can be controlled by using IoT sensors. So that is very much useful for controlling the temperature within the building and how the air quality, how much energy consumption, how we can control the HVAC system to save the energy and how we can monitor all these things, automated control systems. So that is done by IoT sensors. So IoT building sensors are very much useful for controlling the uh, HVAC systems.
Okay, thank you, sir. Next question. How can smart zoning and land use planning reduce disaster vulnerability?
Can you repeat, ma'am?
Shall I repeat? How can
Yes.
how can smart zoning and land use planning reduce disaster vulnerability?
Yes, ma'am. So the main already we discussed here. The land use management is very much important to control the uh, during or even post disaster relief. So that is very much depend on the land use management and how the land use in the particular urban zone or any disaster area. So that is very much important. So if we have a eco-friendly or eco systems along with our urban latest technology planning. So this is easily can be controlled and anticipated disasters, even the impacts, how it can be observed, how it can be recovered quickly. So all these things can be managed in the transform systems by using this urban resilience concept.
Okay, thank you, sir. Next question. What role does real-time data play in emergency response and evacuation planning?
Can you repeat, ma'am?
Okay, what role does real-time data play in emergency response and evacuation planning?
Yes. So data collection, that sensors, even satellite things will be controlled for collecting the data, so that the AI and other big data tools can be used for processing how the data, how the intensity, how the data is collected and stored, so that can be processed, and then command and control centers will give the decision support immediately to action and response from our side or any authority during the emergency, or if is there any just alert or any severity, if there is any service requirement. So that is depends upon the data severity and support the system. So that is given directly to the action and response control.
Okay, thank you, sir.
Good afternoon, sir. One more question that I would like to ask, rather on the discussion on this topic, sir. The
Yes,
the question is that what are the major challenges that we will be facing in case of retrofitting the cities of the ancient cities, ancient infrastructure, to upgrade it or to transform it in the more smart city networks. However, in case of the newer constructions, all these rules and regulations and developments can be taken into consideration. So what is the major challenge which will we have to face in upgradation of the ancient or the structure that is already available and that we want to imbibe them in the smarter city networks, sir?
it's already existing ancient infrastructure and other buildings. So this integration and transforming into IoT and latest smart city technologies. So that is one of the main things. So we have to adopt according to the contemporary challenges and the development. So even though the some of the conventional concepts already which we adopted and which followed in the conventional buildings and the ancient buildings, so that method also available to face this kind of disaster. Even the resilience can be uh, tolerable even if we follow the conventional systems. So even though the smart city technologies are adopted, but this conventional technology also can be considered. So that is also important. We need to consider and can adopt.
Okay. Okay, thank you, sir. Anybody else? Okay, then we will conclude this session. On behalf of the organizing team, I would like to express our sincere gratitude to Dr. Madhyalagan Sumish for delivering such an insightful and informative session. Sir, your valuable inputs, research insights, and clear explanations have greatly enriched our understanding and were truly beneficial to all participants. We deeply appreciate you for sparing your valuable time and sharing your expertise with us. The session has highly engaging and interactive further added value to the learning experience. Once again, thank you very much, sir, for this valuable contribution and support. Next session will be begin at 3:30 p.m. The feedback link has been shared in the chat box as well as in the WhatsApp group. All participants are requested to submit the feedback before joining the next session. Thank you. Thank you all.
Thank you, ma'am.
Thank you, sir.
இல்லடா பரவாயில்ல நீங்க கிளம்புங்க நான் வரேன்
Good afternoon, all. We can start our next session. Before that, we have to take a photo. So I request all the participants to turn on your cameras. All the participants, please turn on your camera for a while. Thank you all for your participation. So we can start our session. I welcome today's resource person Anu ma'am for this function. Anu Vettathu Parambil Velayathan is a system engineer at Global Climate Forum in Berlin, specializing in green growth process, climate risk management, and sustainability analytics. Her work at GCF include research on Berlin water consumption, European forest, and opinion dynamics using HK model. With a master's in civil systems engineering from TU Berlin and a background in geotechnical engineering from IIT Kharagpur. Anu has expertise in climate adaptation and extreme weather impact analysis. She also previously worked on LCAS and decarbonization strategies at IOW and contributed to sustainable design project to IOGAL GmbH. Anu ma'am is an active researcher and speaker presenting on climate biodiversity interaction, wildfire risk, and forest based mitigation strategies. At GCF, she focused on system based solutions for effective climate policy and sustainability initiatives. Ma'am, I welcome for today's session.
Thank you, ma'am. Thank you for introducing me. Is my slides visible? Slides visible?
Yes, ma'am.
Okay, and I'm audible also, right?
Ma'am, you can start.
Yeah. Okay, thank you. This is a platform where it's like knowledge sharing is basically carried out like FDP programs. So I would start with German sharing also, that is like German word sharing, by wishing you all a guten Abend, Fakultaten, that is good evening, faculties. So today's my topic is completely reliant on capacity building and community engagement, which is a very general topic. I won't be dealing much into critical concepts, but would be clarifying more about the capacity building and the community engagement mechanisms that are basically adopted in various countries. So before I start my slide presentation, I would like to engage with a small interactive session. As I could see, there are numerous participants from various places, especially from different states. I would just like to have an interaction in regard with a question that I'm posing for you is, what are the disasters that you have currently seen in 2024 and 2025 in your own state, which can be a natural disaster or an artificial disaster? If possible, could you just type in the answers for it in the chat box? What are the natural disasters that your state had faced? Either it can be a natural disaster or an artificial disaster. since the topic is completely on disaster management, just I wanted to have wanted to get a perspective from which state and what disaster currently your state had. Landslide, why not? Yeah. And is there anything else? Floods, yes, Jammu and Kashmir, absolutely. Maharashtra, natural disaster, flood. Okay, fine. Natural disaster, Kerala, tsunami, Tamil Nadu, natural landslide, Kerala. And anyone else? So basically, these are the natural disasters that our country is facing, like basically landslide, and most prominently, it is the flood disaster, which has a higher impact in our country. So moving on to the basic topic, that is natural disaster within India. You can see that basically we have the cloud burst as well as a flood, heat waves and the urban fires, cyclones and the coastal flooding, and also industrial and the infrastructural accidents. So if I take into consideration the cloud burst and the flood, these sort of a natural disaster is basically seen in the Uttarakhand, Himachal, as well as the Assam area. I need not explain what each of the things are, but primarily I would like to just focus on the region where it is highly prominent. Moving on to heat waves and the urban fires, it's more predominant in North and the Central India. And then you have the cyclones and the coastal flooding, which is in the eastern coast and the Bay of Bengal region. And then comes the industrial and the infrastructural accidents. Recently, an industrial accident has occurred where in Nagpur, around a 10 lakh liter tank was actually burst. So it includes the industrial and the infrastructural accidents, predominantly includes the tank burst, factory mishap, and the construction failures. Now, out of all these four things, which of these disasters do you think pose the highest risk to human life? Majorly, it is the flood and the cloud burst. That is, the main reason behind it is because it's been stated that it has the major human risk factor. It's because it provides a very little warning, and mostly it is especially if it is in the region of hilly regions, the disaster would be at a higher level. And moreover, the higher exposure, it can be seen in the rivers and the floodplain and the low-lying areas of most of the country land. And this disaster, that is a flood and the cloud burst, naturally do have a cascading impact. Cascading impact means it does give rise to many other disasters. For example, landslides, building collapse, road washouts, and power failures. And what are the challenges associated with this particular, very little warning, but a higher risk natural disaster? It's nothing other than, if it is happening in the nighttime events, naturally, in order to have an evacuation procedure to be carried out, it's highly risky. And even in the case of roads, especially the Himalayan regions, if the regions are having roads with lots of gutters or lots of, uneven surface roads, then of course it can be explained as like a poor access road. And moreover, limited shelters even of course lead to increased fatalities. Now, moving on to the section 1, that is related with understanding the capacity building in disaster management. I would like to quote what this capacity building is. Basically, it refers to the strengthening of the skills and the systems and the resources, and so that the communities, professionals, as well as the government officials can actually effectively prepare as well as respond to and recover from various disastrous effects. Now, there are certain key components for this capacity building. The first one is skill development. For example, If I take into consideration, if I take this training engineers in earthquake resistant structures. So if you see most of the institutions that is available within India, we do have masters in earthquake engineering. So we are building people who are able to design structures which are really earthquake resistant enough. Moreover, if some organizations are providing some training engineers, even after their graduations or even after enrolling, if not enrolling, rather, even after joining in certain firms or organizations, most of the organizations do provide training to engineers, especially in the field of this earthquake resistant structures. And moreover, we do have another skill development, which is known as the disaster response drills for first responders, which means like, especially I have seen when I was doing my software intern in Infosys, we did had response drills wherein we will be some alarms will be put on, and then we have to find the evacuation routes, run off, and to reach up a certain region where it is particularly safe. So by this procedure, actually, we are being trained how to tackle up a disaster and be, highly, what do you call, at a very limited amount of time, how we can save our own life. We are being trained in this particular aspect. So these two things are the basic main, what do you call, examples that I can quote in regard with the skill development, in regard with capacity building. Then comes institutional and system strengthening, which is like training, establishing some early warning systems for cyclones, or some developing some emergency operation centers, and also creating some standard operating procedures for disaster responses. It's completely institutional strengthening mechanisms, so which basically builds reliable systems that can coordinate across agencies, and thus reducing most of the confusions and delay some the disastrous events. Moving on to the community preparedness. In regard with the community preparedness, it's totally related with the people residing at a particular region. So it's like community-led evacuation planning. This comes under the capacity building. Then you have the local disaster volunteers trained in basic rescue and the first aid, and awareness programs on flood-safe housing practices. These three planning mechanisms, basically what it does is empowers communities to become the first line of defense, reducing loss of life before external help even arrives. Moving on to the next segment, that is resource and infrastructure enhancement. So we have stockpiling emergency materials. So in terms of flood disaster, we can flood disaster, or whether it is a landslide disaster, not only sandbags or shelters, but also food piling are also taken into consideration for stockpiling emergency materials, strengthening critical infrastructure like bridges, hospitals, and roads. Then you have use of climate resilient construction materials. And these basically ensures the availability of physical and financial resources needed for a very rapid response and very faster recovery system. The next slide is completely about the importance of, importance in disaster preparedness. So when we are getting prepared for the disaster, natural disasters or the artificial disasters, we are basically enhancing the resilience, also reducing the vulnerability and improving the coordination. So if I take into consideration the enhancing resilience methodology, it is like capacity building, basically strengthen the ability of the city's infrastructure systems and the communities to anticipate, absorb, and recover from shocks caused majorly by the disasters. So for example, if I quote, it's like in Netherlands, we have flood resilience system where a Delta program has been implemented, which combines engineering capacity, which is like dikes, storm surge barriers, with institutional capacity like long-term planning and governance, enabling the country to withstand extreme flooding events. And in Germany, we have some strategies, especially related with climate adaptation strategy, where local governments are trained to integrate climate risk assessments into urban planning, improving resilience to heat waves and extreme rainfall. Now, impact of all this enhancing resilience is that infrastructure and communities continue functioning even during the crisis, minimizing the economic as well as the social disruption. Moving on to the second point, that is reducing the vulnerability. Basically, it is the preparedness or focus. Capacity building reduces the exposure and sensitivity to hazards, especially for high-risk populations and the critical assets. If I quote the examples, it would be in Italy. Some seismic retrofitting techniques or programs are basically conducted, like capacity building program for engineers and municipalities for improved earthquake safe building retrofits, reducing collapse risk in historic cities. And in regard with the Spain, we have heat wave action plans, like training local authorities to identify vulnerable groups, especially elderly and the outdoor workers, thus to reduce mortality even during the extreme heat events. So impact of this reducing the vulnerability naturally is fewer casualties, reduced infrastructure damage, and lower recovery cost. Moving to the third point, that is improving the coordination, which is like disaster preparedness basically depends on effective coordination among the institutions, sectors, and the borders. It's like a core outcome of capacity building. So in EU, that is EU civil protection mechanism is adopted, which is like member states share training, resources, and rapid response teams, enabling coordinated actions during wildfires, floods, and earthquakes. Then we have Copernicus Emergency Management Service, which is like builds technical capacity by providing real-time satellite data for disaster mapping and decision-making across EU countries. So impact of this improved coordination is faster response times and better informed decisions and reduced duplication of efforts. Moving on to the stakeholders that are combinedly active in this capacity building is government agencies, local communities, NGOs, and international bodies. So if I focus on government agencies, then the role of these agencies are basically to develop policies, laws, and national disaster frameworks, which allocate funding for preparedness and resilient infrastructure as such, and coordinate emergency response across different sectors too. A best example that I could pose before is like a National Civil Protection Authority, which implements various risk assessments and emergency plans. And EU Civil Protection Mechanism, which is also termed as UCPM, enabling cross-border assistance, joint training, and shared resources. And even some local municipalities also integrate climate risk into urban planning and building codes. So why this is quite important, that is, what is the role or what is the importance of this government agencies is basically provides a leadership, authority, and long-term planning, ensuring disaster preparedness in institutions rather than ad hoc ones. Moving on to the local communities as such, basically the role that they play is they act as the first responders even during the disasters. That is participate in risk mapping, early warnings, and even evacuation planning. It even maintains a local knowledge of all the hazards and the vulnerabilities of a particular region. So if a community flood committee is there in Germany and Austria, which basically manages all this local flood responses, and even some citizen volunteer networks that support wildfire response mostly in Southern Europe. And participatory planning for resilient, climate resilient neighborhoods are also present in major countries like Scandinavian cities, like Denmark, Sweden. And why it's quite important, it's about the strong community capacity, which reduces the response time and saves majority of the lives and also improves trust between the authorities as well as the citizens. And the third and the important one is also the NGOs and the international bodies, which provide a technical expertise in training and funding. So support also vulnerable populations and post-disaster recovery mechanisms too. So it also facilitates knowledge exchange and innovation ideas. For example, we have this Red Cross, which is like an emergency preparedness, a training and humanitarian response. And a very famous one that is UNDRR, which is termed as United Nations Office for Disaster Risk Reduction. It is basically a framework it's like Sendai framework, which guides EU disaster policies. And also, which is one NGOs or international body. It is the World Bank and the European Investment Bank, which actually finances resilient infrastructure and risk reduction in projects. And what are the importance of this is like it bridges the gaps in capacity and also introduces the best practice and support countries with limited resources. Now, it does have some challenges in implementing the capacity building. The first and the major challenge is lack of funding. So insufficient financial resources basically limits the investment in early warning systems, resilient infrastructure, training programs, and emergency equipment. Therefore, the disaster risk reduction basically competes with short-term development priorities. Now, if I take a few examples in econ is delayed retrofitting of aging bridges and public buildings, which we can basically see in our own country. So it's like limited funding for climate risk assessments at local levels and dependence on post-disaster aid rather than preventive investment. And the consequences of all this lack of funding mechanisms is basically increased loss of life and property, and even higher term recovery cost, and reactive disaster response instead of proactive preparedness. And the second challenge associated with the capacity building or implementing this capacity building is weak institutional system, wherein weak governance basically structures unclear responsibilities and lack of coordination between various agencies, reducing the effectiveness of disaster preparedness and response. So overlapping, which mandates between the urban planning and disaster agencies is a certain example for this weak institutional system. Poor data sharing between meteorological, planning, and emergency departments. Even absence of some standard plans or operating procedures are also weak institutional systems. So the consequences of this weak institutional systems could be delayed emergency response and decision-making, insufficient use of resources, and reduced public trust in institutions. And third important point is low awareness levels, wherein limited understanding of the disaster risk among the communities, local authorities, as well as even the professionals, of course, lead to poor preparedness and unsafe practices. So construction in floodplains or seismic zones without risk consideration is a best example for this low awareness levels. So low participation in evacuation drills, also underestimation of the various risks associated with heat waves and urban flooding are also related with low awareness levels. And its consequence can be highly vulnerable to most of the people as well as the infrastructure as such. So increased casualties due to delayed or incorrect response is also a consequence of this. And repeated damage cycles and slow recovery are also the major consequence in association with this low awareness levels. Moving to the successful capacity building models, we have three basic models, that is community-based disaster risk management, public-private partnerships, and local leadership networks. If community-based disaster risk is taken into consideration, which is also termed as CBDRM, it is a bottom-up approach where communities basically identify, plan solutions, and implement actions with technical support from authorities as well as some experts. So what are the key features associated with it? It is preparatory risk mapping, community disaster committees, and local preparedness and response plans. And majorly, why this actually works, or community-based disaster risk management, why it works is like for high local ownership as well as trust and fast response in case of emergencies. And also it is a solution tailored to real local people around a city or a state. Moving on to the public and the private partnerships, we have collaborations between various government, private sectors, and service providers to actually strengthen disaster preparedness and response. And the key contributions of this particular public and private partnerships are basically technology and innovation from the private sector, infrastructure investment as well as maintenance, logistics and supply chain support. And BEC's examples is the telecom companies which actually support some SMS emergency alerts across a country. And even some construction firms actually contributing to resilient infrastructure designs. And insurance companies also play a major role in this public-private partnership, which promotes risk-informed planning. And how it basically works is based on the mobilization capacity, additional to funding as well as the expertise, speeds up by deployment of various solutions, and also it also enhances the scalability and sustainability aspects. Moving to the local leadership networks, it is of a network of trusted local leaders, especially the government officials like elected representative, community leaders and teachers, health workers and volunteers, who basically act as connectors between the institutions and the communities. And the key roles associated are to disseminate early warnings and guidance, and coordinate with community preparedness between various activities, and mediate trust between authorities as well as the residents. And the best example would be ward level disaster coordinators and school principals and healthcare officials leading to local drill, and volunteer leaders basically managing the shelter and the relief distribution mechanism. And majorly, this local leadership basically messages are being entrusted and acted upon, and also gives a social, it is inclusive of various social groups, which coordinates during all the major crises. Now, going to the second section, that is the community engagement, that is the heart of the disaster resilience as such. That is why the community or the community engagement basically matters. Now, the community engagement matters basically because of the community are the first and the foremost responders, and local knowledge also improves the planning mechanisms, and also it builds a trust and collective action. So if community engagement is actually widely recognized as one of the most critical pillars of disaster resilience, in most disasters, basically local communities are the first responders long before external emergency services even arrive. So neighbors help evacuate, provide first aid, share food and shelter, and water, and also support vulnerable populations. So this makes community preparedness not optional, but rather an essential thing. A very strong example for this community engagement is in Japan in 2011, Tohoku earthquake. In several coastal towns, basically the communities that had regularly connected local evacuation drills and disaster education basically experienced significantly lower casualty rates, and residents knew evacuation routes. The local people over there basically knew the evacuation routes and understood tsunami warnings and acted collectively within few minutes. So this demonstrates how community engagement directly saves lives. And another key reason is community engagement matters the most is the value of local and indigenous knowledge, where communities understand local terrain, drainage patterns, flood-prone streets, and safe shelters for far better than the external planners. For example, in India, if we take the Kerala floods in 2018, we could see that the local fishing communities played a crucial role in rescue operations using traditional boats. So their knowledge of water currents and local geography enabled faster and safe evacuations when formal rescue forces were overwhelmed. Now, even the community engagement also helps build trust and collective actions, which is essential during the emergencies. So when people trust authorities and feel included in decision-making, they are more likely to follow evacuation orders and preparedness guidelines. In Bangladesh cyclone preparation program, which is like stated as CPP, BCPP, which has been active since 1970s, and significantly strengthened after Cyclone Cedar, that is in 2007, and Cyclone Amphan in 2020. Volunteers from local communities were trained in early warning systems and evacuations and shelter management. So as a result, cyclone-related deaths have dropped dramatically over the decades despite increasing storm intensity. Moving on to the types of community participation, we have three basic community participation, which is like consultative, collaborative, and community-led initiatives. So we take into consideration there's consultative participation, which is like authorities and experts who seek inputs from the communities, but decision-making basically remains within the major institutions itself. That is known as the consultative one. And the public consultations on flood zoning map is a particular example for that. Even some community feedback on evacuation routes. So what are the role of this in resilience? That is a role of consultative participation in resilience. It actually improves the accuracy of risk assessments and even ensures local knowledge is also being considered to a primer level. And it does have a limitation. That limitation is, of course, the engagement is basically only in one level or one way, which may not guarantee implementation of community suggestions. And in regard with collaborative mechanisms, which is like communities and institutions basically co-design solutions and share decision-making responsibilities. So it could be the government firms, or it could be the institutions where researches are being carried out. So it might be a collaborative mechanism. For example, it's like a joint planning of neighborhood disaster management plans or community participation, urban resilience and climate adaptation projects, or co-development of early warning dissemination systems comes under this collaborative participation. And its major role in resilience is it basically strengthens between citizens as well as the authorities, and it leads to more realistic and accepted solutions. And moving on to the community-led initiatives, we have communities which basically initiate and manage and sustain disaster risk reduction actions among themselves. For example, we have the volunteers basically run early warning networks or community manage flood shelters or local disaster response teams trained in first aid and rescue. And their role as majorly in resilience is a faster response even during the emergencies, and build self-reliance and long-term capacity. Moving to the local knowledge integration. The local knowledge integration, basically, it involves the traditional warning system that is adopted throughout, and local resource networks and culturally relevant information. So in regard with the traditional warning systems, we have this changes in animal behavior, that is birds moving inland before the storms are a best example of traditional warning, or sudden water color change or flow changes in rivers indicating upstream flooding. Even some coastal communities noticing unusual tides or wave patterns. So what are the values of these traditional warning in disaster management? It basically provides early localized alerts and complements meteorological forecast, and also helps communities act very quickly when formal systems basically fail. And in regard with the local networks, resource networks, these are the communities who actually explains the or who knows who what and where the resources are basically available locally during the emergencies. For example, if we take the case of Kerala itself, our local fishermen, which actually provided the boats for flood rescue, our local resource networks, and community halls or the schools, which could be termed as a temporary shelter, or even informal neighborhood groups distributing food and medicines are also taken as an example for local resource networks. And what are the values in regard with the disaster management? It's like enables rapid response in the first critical hours and reduces dependence on the external aid as such. And also it improves the efficiency of relief operations. And the third local knowledge integration is culturally relevant communication. That is like, it's a risk communication that respects local languages or symbols, customs, or trust networks. For example, we have disaster warnings delivered through local leaders or religious institutions, or we use some folk media, street plays or community radios in order to transfer knowledge, and visual signage using locally understood symbols instead of technical jargon. And the values that is associated with the disaster management is basically it ensures proper warning, which are understood and trusted, and increases compliance with evacuation orders and reaches vulnerable and marginalized groups. Moving to the next slide, that is in association with the building trust and communication channels. The first very important point is the transparent risk communication, which means sharing accurate, timely, and honest information about the risk, uncertainties, and possible impacts before, during, and even after the major disasters that had occurred. So, for example, we have the public dashboards showing flood risk maps and warning levels, or some clear explanations of what is known and what is unknown, even during the extreme weather events, and regular updates from various authorities through verified channels. So what are the impacts of the transparent risk mechanism in building trust? It actually reduces some rumors and misinformations and builds some credibility and long-term public trust, and encourages an early action and compliance with most of the warning systems too. So thus it's quite essential. That is, transparent risk communication is quite essential in building trust and communication. Now, moving to the second point, that is community meetings and drills. It is engaging communities through face-to-face interactions and practical simulations of disaster scenarios. For example, we have neighborhood level evacuation drills or community workshops being carried out on safe shelter locations, or school-based disaster preparedness exercises. And the impacts of this community meetings of the drills could be which improves various awareness and the readiness among the society, and clarifies various roles as well as responsibilities associated, and it builds confidence to practice and not theory. Then moving to the third one, that is the leadership involvement. It basically means it's a visible, accountable involvement of leaders, local leaders, or the elected representatives and some trusted figures in disaster preparedness and response. So it includes some mayors or local officials leading to public preparedness campaigns, or it could be community leaders disseminating warnings and guidance, and some trained volunteers which could act as the risk communication focal points. And the impacts associated on this building trust is it enhances the trust in official messages. It ensures messages reach all sections of society and strengthen coordination between the communities and the authorities. Moving to the barriers that are to the effective participations, first one is social inequality. That is, even social and the inequal, that is economic inequal, limit people's ability to access information, participate in planning, and recover from disasters. So vulnerable groups often face higher exposure to risk and fewer resources to cope on. For the informal settlements, basically located in flood-prone or landslide areas, are best examples for social inequalities, and some elderly or migrants or low-income groups lacking access to digital warning systems. Also, some gender-based barriers restricting participation in decision-making. So what are the consequences associated with such a barrier? That is social inequality. It is disproportionate disaster impacts on marginalized communities. We have slower recovery and deeper poverty traps, and reduced overall community resilience. The second important point in regard with the barriers is low participation, which could be like limited engagement occurring when communities feel their voices actually do not influence the various decisions taken, or when participation processes are inaccessible or time consuming. So for example, we have this poor turnout at disaster preparedness meetings, or lack of incentives for volunteers, or we have community fatigue due to repeated consultations without visible outcomes. And the consequences basically leads to plans that do not reflect the real but local needs. And weak ownership of disaster strategy is also a consequence of low participation. And along with that, reduced effectiveness of evacuation and response measures. And the third and the foremost important point is a communication gap, which is like a breakdown in communication between various authorities or communities, which basically could be due to some misunderstanding or delayed or ignored warnings. And it could be like a technical language basically not understood by non-experts, or inconsistent messages from different agencies, or limited outreach to remote or digitally excluded populations. And it also provides some sort of consequences to that is like confusion and panic during emergencies, and also delayed response and unsafe actions, and also the erosion of trust in between the institutions. Moving to the third part, that is the tools, methods, and training for capacity building. That is, in regard with some training programs and the workshops that are majorly carried out as a part and parcel of tool mechanism adoption for capacity building. The first, that is the first aid training, which in PR or bleeding control, some injury stabilization until professional help basically arrives. And these examples could be like community volunteers trained in some medical emergencies, or first aid training for teachers and public transport staffs. And it does do have an impact. This first aid do have an impact, which is like saves lives even during the critical first minutes, and reduce pressure on emergency services. The second training program or the workshop could be on evacuation training systems, which basically includes some safe evacuation routes, shelter identification, or even crowd management and assistance for vulnerable groups. And flood evacuation drills are some examples for this and even cyclone evacuation. So the impacts of these evacuation training programs could be some faster and a safer evacuation, and also a reduced panic and chaos during the emergencies. And the third training program is related with search and rescue, which basically includes some rescue techniques or use of some tools and safety equipments or mechanisms, and coordination with some professional responders. So if we plan some community disaster response teams, that falls under the search and the rescue training program or the team as such. And moreover, some rapid rescue, it do have an impact. That is, the search and rescue system do have an impact. That is, it provides a rapid rescue in first critical hours. The moving to the second one, that is rated with the institutional level, that is school and workplace awareness programs, which includes basically the age appropriate disaster education and mock drills and the emergency response roles. For example, we have the earthquake or the fire drills in schools, or climate risk education being integrated into the curricula. And the impacts could be like build a safer, a culture of a safety vary from the young age itself, and children become messengers of preparedness even at being at home. And then we have this early warning system, which is basically a technology which is used to make people aware of various disasters that has occurred or might occur. So this early warning system, it basically provides a timely, reliable information that enables authorities and communities to act even before the disasters even strike, significantly reducing loss of life and damage. The first one is the SMS alerts, which is totally location-based emergency message or hazard-specific system. It can happen up either in the case of a flood, cyclone, or a heat wave. And basically the cell broadcast alerts even during the extreme rainfall or the heat wave situations. And the SMS evacuation warnings are sent in even multiple languages. So what are the strengths associated with the SMS alerts? It's fast and wide coverage, but reaches people directly on personal devices. But it do have a certain limitations. That is, it depends on the mobile network availability, and even may exclude some elderly or digitally disconnected populations. Moving to the second point, that is the sirens broadcast or the public broadcast system. What it includes is fixed sirens in the coastal areas or industries or flood-prone areas. Even public address systems or radio broadcast include the sirens or the public broadcast systems as such. The examples could be like in tsunami and cyclones, sirens, basically it's seen in coastal regions, or emergency announcements, which happen up in community radios and TV. And the strength associated with such a system could be like effective even when mobile networks do fail, and reaches basically a very large crowds. Limitations are also there for this particular sirens or broadcast system, which is like limited information content or requires public awareness of various siren meanings. Moving to the third one, that is the weather forecasting and the monitoring tools. What it includes is meteorological satellites and radar systems, or even some rain gauges or river level sensors and heat monitoring stations, and some impact-based forecasting models. So examples related with this weather forecasting or monitoring tool could be a flood forecasting tool, which is like a rainfall runoff model, or heat wave early warnings based on temperature and the humidity thresholds, or some storm tracking with Doppler radar and satellite imagery. And the strength associated with such weather forecasting could be like provides lead time for the preparedness, and it supports mostly the evidence basically related with the decision making. And the limitations or the disadvantages in regard with the weather forecasting is it requires technical expertise and data integration, and even uncertainty increases for some localized extreme events. Similarly, we have some simulation exercises that's been carried out in various countries, like we have the mock drills, tabletop exercises, and scenario planning. In regard with the mock drills, those are basically the full-scale practical simulations that basically replicate real disaster situations, even involving some people or equipment or emergency services. For example, earthquake evacuation drills in schools and offices, or the flood evacuation and rescue drills in urban neighborhoods, or fire drills in hospitals and high-rise buildings could be part and parcel of the mock drills. And the purposes or the benefits that it basically serves is it tests the evacuation routes and response time. It familiarizes between the people with emergency procedures, and also reduces the panic and confusion during real events. The next one is like a tabletop exercise where the discussions are completely based on some simulations, where basically the decision makers walk through a disaster scenario using some maps or charts or some responsive plans. So like in city officials, basically simulating a major flood response as a small example for it, or some emergency managers basically discussing some heat wave impacts on healthcare system, or interagency coordination exercises for wildfire management. And the purposes or the benefit that it serves as a new technique. It improves decision-making and coordination. It also identifies policies and communication gaps. And also it's a very low cost affair and easy to organize. And the last one is scenario planning. Basically, it is like a forward-looking method that explore multiple plausible disaster futures, often linked to climate change and urban growth. For example, we have the planning for some extreme rainfall, even under climate change scenarios, and some coastal city preparedness for sea level rise and storm surges falls under this scenario planning. And the purposes that it serves is like it supports a long-term resilience planning, and it helps prioritize various investments as well as some policies. Moving to the next one is the digital tools and the various platforms that we can generally see is there are different platforms which are used for this capacity building. For example, we have the GIS mapping, mobile apps, and data dashboards. In regard with the GIS, it basically integrates the visual hazards, exposure, and the vulnerability across a different region. And it is mainly used for flood risk and inundation mapping, or in regard with some landslide susceptibility or seismic zoning, and even mapping of evacuation routes, shelters, and critical infrastructure. And benefits associated are majorly oriented towards some support risk informed urban and infrastructural planning mechanism. It improves emergency response coordination and also helps prioritize high risk areas and populations. Moving to the second digital platform, that is mobile apps, are basically the smartphone-based platforms that connect authorities, responders, and citizens before and during the disasters. And it's like emergency. Some examples are like some emergency alerts or warning apps, or apps for reporting damage or hazards, or volunteer coordinations and shelter information platforms. And some advantages associated with those mobile apps could be like real-time and two-way communication is fast possible. And it improves public awareness and preparedness, and also it enables a fast response and feedback system. And the third one is data dashboard, which is like a centralized digital interface which displays the real-time and historical disaster-related data. And uses or the examples could be like a weather hazard monitoring dashboard, or an emergency response status and resource tracking, and even some post-disaster damage and recovery monitoring. And the benefits associated could most probably be enhancing situational awareness for the decision makers, or even it supports transparent and coordinated response, and it enables evidence-based planning and policy decisions. Now, in regard with the next slide, that is the policies and the frameworks associating the supporting capacity building, in which the first one is the Sendai framework or Sendai policy. It's mainly for disaster risk reduction, implemented in 2015, and it has a span for 2030. And it's a global UN-led frame network which guides countries to reduce disaster risk and losses in lives, livelihoods, and infrastructure. The key priorities are to understand various disaster risks associated, even to strengthen some disaster governance, or invest in some disaster mechanism, also to enhance preparedness, or termed as build back better. So why the Sendai framework basically matters, it actually shift focus from a disaster response to risk prevention, and it also promotes inclusive, people-centered approaches. And it also aligns with some disaster risk reduction with climate implementation and sustainable development. Moving to the next policy, that is the National Disaster Management Policy, where it is completely country-specific laws or strategies and action plans that translate global frameworks into local implementation. And the key elements could be like hazard risk assessment and zoning regulations, or roles and responsibilities of various agencies, and funding mechanisms and emergency response protocols are the major key elements associated with this national disaster management. And the examples could be the NDA, that is the NDM, that is the National Disaster Management Acts, as well as the plans in our own country, and sector-specific guidelines for infrastructure, health, and urban planning. And why do this national disaster management matter? It basically provides a legal authority for actions to take into actions and ensure consistency across various national, state, and local levels, supporting long-term capacity building. And the third one is the institutional coordination mechanism, where we have some structures and processes that enable effective coordination across multiple stakeholders involved in disaster management. It could be like an interministerial cooperation committee, or it could be emergency operation centers, EOCs, or standard operating procedures known as like SOPs. And they do matter, because it avoids duplication of various efforts, and it improves information sharing and also response efficiency during various disaster, and also enables rapid and well-coordinated action even during the emergencies. Last section is about the case study and the real-time world application, wherein we have a certain case study associated with Bangladesh cyclone preparedness program, Australian community fire management, and Netherlands flood resilient communities. So if I take the real world case studies, which demonstrate how basically the capacity building and the community engagement that translate into a tangible resilience, This Bangladesh Cyclone Preparedness Program is one of the world's most successful disaster resilience model, and it deploys more than around 70,000 community volunteers who support recovery. And the integration of government agencies, NGOs, and local communities has drastically reduced cyclone-related fatalities over the last decades in Bangladesh. And moving to the Australian community, in Australia, the community fire management strategies basically illustrate how local participation saves lives even during the bushfires. So volunteer fire brigades basically play a critical role educating communities on fire-resistant buildings designs, evacuation communities on fire-resistant building designs, and evacuation procedures and wildlife behavior. So public awareness campaigns basically helps residents understand how to create defensible spaces or reduce fuel loads and react even during the fire outbreaks. And the third case study is in regard with some Netherlands flood resilient, wherein it provides another exemplary model through its flood resilient community, where with much of the country being below sea level, basically the Dutch have learned to live with the water rather than fight against it. So it said that the Room for the River program basically combines engineered infrastructure with nature-based solutions, which where local communities help some design flood strategies, and also this integrated approach in Netherlands protects citizens and preserves ecological balance. And there are some few lessons which can be taken away from the case studies which happen in Bangladesh, Australia, and Netherlands. It's like community leadership, technology must be accessible to all, and moreover, consistent practice through drills or transparent communication and trust building makes the communities very stronger. And these models basically can be adopted across different countries, provided they respect local culture, geography, and socioeconomic conditions. Now, moving on to an interactive session, that is majorly we have seen that we have flood or a cyclone scenario in our own country. So if we basically take an example of a coastal city in India where the population is over 1 million, and there is a rapid urbanization. And even we have got some sort of informal settlements near to the river or the coastal areas, and some sort of very aged stormwater drainage, with also the area near to this coastal city is having some poorly critical infrastructure, like, critical infrastructure like hospital, power substation, or metro line, basically located near to some low-lying zones. If a city of that sort is taken, then what do you think from structural point of view, or environmental point of view, or water resource point of view? What could be the major capacity building or community engaged mechanisms that could be adopted prior to a disaster, like a flood cyclone scenario disaster? It is a interactive session here. So I would like to know if in regard with a flood or a cyclone scenario, as we are from the civil engineering background, what could be the capacity building mechanism or the community engagement mechanism that could be taken prior to the disaster, flood disaster? If any suggestions are there, you could post it in the chat box related with this statement, that is in flood and cyclone scenario. Suggestions in the sense, I'm repeating again, it is some capacity building or community engagement mechanisms that could be adopted very prior to flood. Answers could be posted in the chat box. I think most of them are at, let's see, 1 second. How should the effectiveness of capacity building community engagement should be measured in post-disaster scenarios? Post-disaster scenarios, especially if are taking into consideration with this flood, especially in coastal regions, the post-disaster scenarios could be providing shelters, food mechanisms, and some arrangements being done to provide a proper shelter. That is answer for ocean. And some alert-based mechanism on climate prediction. Okay. That is true. That is in regard with alert-based, it is not, what do you call capacity? Yeah, alert-based mechanism. That is prior to the cyclones or the floods, basically we can have some alerts being carried out through this apps or SMS services that's there, or any other mechanisms that could be adopted, or any other training programs or tools that could be used prior to the disaster. At least we could find out the zones that are under high risk. That is, if a region is taken or a coastal area is taken, if we have data related with prior flood, if supposedly if we are taking the case of 2025, and we need to know what are the capacity building or engagement measures to be taken right now, then if we could see a lifespan of about 20 or 30 years, and we could see how far or how extent the flood had affected a particular zone, based on which we can plan some evacuation methodologies, or even some evacuation what do you call campaigns could be done, or some drill mechanisms could be implemented as such. So these are the post-development methodology that could be adopted in regard with capacity building. So moving to the conclusion part, basically some of the key points in regard with capacity building of the community engagement is capacity building strengthen the skills as well as the various systems. It also ensures real resilience. It also turn knowledge into actions and provide some case, collaborations is also quite essential. So this disaster management is not the responsibility of a single institution, but rather it's a shared effort that requires strong capacity and engaged communities, effective technologies, and collaborative frameworks. So the capacity building basically equips people with skills and knowledge needed to respond to hazards. And community engagement also ensures that the resilience grows from the grassroots. Tools, methods, and policies also convert the preparedness into a practical action. And the real world examples basically show that integrated, inclusive, and approaches can reduce the disaster impacts and save countless lives. Therefore, a disaster resilient infrastructure future depends on empowering communities, strengthening institutions, and adopting adaptive and technology-driven approaches. By combining these pillars, and societies can actually withstand various disasters, but emerge stronger, safer, and more united. Thank you.
Hi all, it is a time for your queries. Participants, please post your queries in the chat box.
Educational institution being a research oriented, of course, can have gather information regarding, if suppose an institution is in India, then we can have an explanation. 1 minute, I just got off track due to another comment. Okay, what are the key components of effective capacity building for disaster management in education institution? Yeah, if I'm taking into consideration Kerala itself, it's a state which is majorly prone for flood. So we have numerous institutions or research-oriented organizations here. So if you could collect most of the data related pertaining to various years of where the flood disaster had occurred. then we could build some mechanisms, or we could build some what do you call, even some apps could be developed within the institutions, and some apps in regard with prior warning system apps could be developed within the institution itself. I think that is the, in regard with the use of education systems in terms of capacity building, that is the best example that I could deliver.
Thank you, ma'am. Any other queries? Anyone? If there is any queries, please text the queries in the chat box.
Ma'am, I have one doubt. What obstacles might institutions face while implementing community-based disaster management programs? And how exactly they can be addressed?
Once again, please. Once again. 1 minute.
Ma'am,
Yeah.
mm,
Yeah, I'm hearing you. Once again, can you just ask me again? I can't.
what obstacles might institutions face while implementing community-based disaster management programs, and how they can be addressed?
Basically, in the regard with the community-based mechanisms that could be adopted in institutions, is like we need to have some permissions from the governmental level. That is the major obstructions that we could face. And huge investments, because if it is the development of some apps or some websites or some early warning systems or campaigns or training systems, of course, it needs huge investment. So it is for that we need to have a proper proposals being get readied and then go for funding, or else we have to approach the government officials so that they would provide us with the funding. Yeah, that was the answer.
Hi, ma'am.
Yeah.
Which community engagement strategies do you believe are the most impactful for enhancing the disaster resilience at local levels?
In regard with the local levels, it is basically some sort of informations or trainings given at the local community for the local people, because as you know, the local communities won't be much trained or educated in that perspective, so they won't be able, knowing even, yeah, of course, in a particular place, if the disaster is happening every year, of course they would be knowing, but they won't be knowing the proper mechanisms of evacuations or proper mechanisms adopted or technology adopted by which they can actually save their lives. So they should be provided with some workshops or training skills, or some knowledge sharing at within the community level, local community level.
Okay, ma'am. Thank you.
Mail ID of the resource person will share in the FD group, so FTP group soon.
Yeah.
Anyone else? Ma'am, there is a question in the chat box that how aligned are current state and national disaster management plans with actual ground realities?
The best way that I could reply to this particular question is like how far we could save lives of lakhs of people who have lost their shelters, lost their lives during the recent flood systems, whether I take in the aspect the Himalayan regions or the Kerala, it is flood regions. So how much people we have indeed lost, or how much infrastructure we have lost. So that itself explains the management plan capacity of our country. How can the concept of capacity building and community engagement be integrated in engineering curricula for better preparedness? That is a very nice question. So this is what I also wanted to focus on. That is, in regard with that, that's basically the implementations of technological aspect like AI, app development, etc., could be taught, or even this what do you call, some courses related to with the disasters, especially some specific courses, like if it is a flood, if our country is majorly facing the flood, then flood disaster courses, such that when we are imparting knowledge to the younger generation, they are able to deliver those such ideas even to the local communities that is nearby. So that is answer for Parvanendu sir.
Thank you, ma'am.
Yeah. Yeah, even I wanted to quote one more thing in regard with this question. That is, if we had some certain courses like integration collaborative system. So this integrated collaborative system is like a mechanism wherein we collaborate between different domain or disciplines. Where, for example, we have the water resource management, we have the what do you call, structural design management, geotechnical design management. So if we are taking into consideration highly a region, especially a coastal region, and if a team of people are completely who are working in this particular domains are completely cooperating and collaborating on developing some capacity planning or capacity building mechanisms together, it is termed as integrated collaborative mechanism. And this particular course mechanism was there in our curriculum also. So just I wanted to have a point figured to you, sir. Parvanendu sir, thank you.
Any other questions? So I hope everyone completed the queries. So we can move to our vote of thanks session. We come to the end of our second session. A sincere thank to our esteemed resource person for such an enlightening session on capacity building and community engagement. The insights shared today regarding this topic have been incredibly value and thought-provoking. So I thank our esteemed guests for this session. So participants, please stay connected as we will resume shortly for our third session today. Thank you, ma'am. Thank you all.
Thank you.
The feedback link for the session 2 is loaded in FDP WhatsApp group and also in chat. Please fill the feedback form. And the next session will begin at 5 p.m. Sir, can you please share your PPT to check it's working properly? Sir, Samuel sir. Samuel sir, can you hear me?
Yes, I'm here.
Can you please present your PPT to check whether there is any problem in presenting it?
Can you please check?
Yes, sir. It's visible. Okay, our third session of FDP for day 6 is about to start. A small request to the participants before we begin. In case of any technical difficulties, audio video issues or connectivity problems during the session, kindly communicate through the official FDP WhatsApp group and our organizing team will assist you promptly. Me myself is Darin Jorsey, Assistant Professor of Civil Engineering Department from ICE College of Engineering. Respected dignitaries, faculty members, and dear participants, a very good evening to all. It is my pleasure to welcome you to the final session of this AICTE Atal Academy sponsored Faculty Development Program on Disaster Management and Resilient Infrastructure. We are delighted to have with us Engineer Samuel Edukula Thomas for his second session in this FDP. We have sincerely thank him for continuing to share his expertise with us. Mr. Samuel Edukula Thomas holds a BE in Civil Engineering from Satyabama University, Chennai, and MTech in Structural Engineering from Christ University, Bangalore. He is a Director of Gopher Developers and Senior Structural Consultant with professional experience in structural design and sustainable engineering. He has also contributed to research through published journal paper on sustainable concrete materials. Today, he will be handling session AI, IoT, and Big Data in Disaster Management, a topic of great relevance to technology-enabled resilient infrastructure. Once again, we extend a warm welcome to Engineer Samuel Edukula Thomas and look forward to an insightful session. Sir, over to you.
Thank you.
May begin. Okay.
Thank you. Thanks a lot. Am I audible?
Yes, sir. Yes, sir.
Okay. Thanks a lot. So good evening, Manano. Today I will be taking the section AI, IoT, and Big Data in DM. That is how we can include artificial intelligence or Internet of Things and Big Data in our disaster management techniques. We all know disaster management is a complicated subject because some disasters are unpredictable. We cannot predict these disasters beforehand. So if something happened all of a sudden, what we will do? Actually, what we will do if we are not if we don't know how to handle the situation, we will get stuck, right? So if something is happening like that, we are not like, I mean, common people are not that much. They are not that much experienced in handling these type of disasters. So, if we are like involving AI or IoT and big data in disaster management, it will make our job, or it will make the management of disaster job, it will make it easy. So that is the importance of this topic. So coming to the, sorry, one second. Coming to the introduction, what does a natural or man-made disaster means? Actually, what is a disaster, or what does a man-made or natural disaster means? So natural disasters are caused by Earth natural processes, and generally it's beyond our limits or our hands. So if something like volcanic eruptions, something like landslides, tsunami, and all, these are naturally happening disasters. We cannot like do anything over it unless it happens. When it happens, we have to react on these situations. And in this topic, we will be handling how we can react on the situation, or how we can incorporate our AI tools in a big data tools to into this topic for the reaction of all these natural disasters and all. So predictability, some can be predicted with early warning system like cyclones, while others are sudden. Others will occur suddenly, like earthquakes and all. Okay, in case of natural disasters, some of the disasters are predictable. Yesterday, I think we have like talked about this cyclones and all. So cyclones and all, we will be getting early weather reports and all, so we can predict and we can like get prepared for situation. But earthquakes, maybe sometimes tsunamis, etc., all these things, no, these are not predictable. So it will come all of a sudden, and then we have to like respond. We have to react on these situations. Then what are man-made disasters? So man-made disasters are disaster which is caused by our activities, or it is caused by human activities. It can caused by human negligence, or it can caused by technological failures. Okay, so in the case of man-made disasters, it will result from human intent, error, or system failures. We cannot like predict, often we cannot predict it beforehand. It will happen all of a sudden. Maybe if we are talking about an accident, we cannot like predict an accident before. It will happen all of a sudden. So some of the examples of man-made disasters are chemical spills. We all are aware about the Bhopal gas tragedy. Okay, then dam failures. If all of a sudden, if a dam is failing, what we will do? A war, a terrorist attack, a major plane crash, a maritime disaster, etc., etc. So if any of this disaster is happening all of the time, and we are the cause for this disaster, what we will do, or how we will react to this disaster. So talking about disaster management, it's a systematic process of planning. Disaster management is a systematic process of planning. It's a process of organizing, and it's a process of implementing. What we are planning, what we are organizing, what we are implementing. We are planning, we are organizing, and we are implementing the measures to prevent a disaster. We are planning, we are organizing, and we are implementing the measures to mitigate a disaster, and measures to prepare for a disaster, the measures to respond to a disaster, and measures to recover from a disaster. This is actually what disaster management is. So simply speaking, it's a system of process of planning, it's a process of organizing, and it's a process of implementing some measures to prevent a disaster, to mitigate a disaster, to prepare for a disaster, to respond to a situation, or to recover from a disaster. So disaster management is a tool to deal with natural or man-made disaster to minimize the loss of life and property. So the topic disaster management, it is a tool, and its main idea is to deal with a natural or a man-made disaster to minimize the loss of life and property. That is disaster management. Okay, so this cycle is a disaster management cycle. So it has two sides. On the one side, it's saying before the event or before the disaster, On the right side, it says after the event or after the disaster, how we will react or how we have to handle the situation before the event and after the event. So before the event, what we will do? First, we have to mitigate. We have to take actions. We have to reduce the potential actions to reduce the potential loss and all. Next one is preparedness. In the stage of preparedness, we have to get ready to face the potential disaster. First one is a long-term action. It's a long-term action to reduce the potential loss. In case of an earthquake-prone area, we have like earthquake-prone area, earthquake-prone chart, and everything in our designing boards. So whenever we are constructing, we are building something in the earthquake-prone area, we have to keep that also. We have to keep the standards of earthquake. We have to keep the codes of earthquake-prone earthquake codes during our designing time, right? So we have to design or we have to build a structure which can withstand an earthquake. That is a role of that's a part of mitigation. In that mitigation part, we have to take long-term actions to reduce the potential loss. Another example is in case of coastal areas. Coastal areas, the high tide, low tide, the tsunami, or the coastal problems are there. So the people who is staying over there have to take long-term actions to reduce the potential loss. They have to take precautions. They have to expect a coastal disaster anytime. They have to take potential actions to reduce the potential loss to prevent those disasters and all. Next one is preparedness, the process of getting ready to face a potential disaster. In case of cyclones, I know we will be getting an alert beforehand. So our weather reports and government will be informing us, okay, a cyclone is coming and it will be crossing these areas. In that case, they will be like telling the people, okay, your area is like more critical. You have to like move to some other place, or you have to keep your things safe. You have to like take your elderly people and kids and all along with you, whatever domestic animals or whatever along with you. You have to take them along with you. Like that, the government will give awareness and government will give warning about this. In that case, in that stage, we have to get ready to face that potential disaster because it is sure that the disaster will come. And we have to take all necessary action, all necessary steps to face that disaster. Then the stage is disaster. Then when the disaster happens, we have to respond to that disaster. If immediately, if a disaster is happening, or if with our knowledge a disaster is happening, what immediately we have to do? We have to respond to that disaster. How we will respond? We have to take actions before, during, and after the event. The immediate response to any accident or any disaster is very crucial. We can like respond in many ways. Okay, if an accident happened, actually what we will do? Initially, we have to call a ambulance or something like that, or fire force or something like that. Then we have to go ourselves there and we have to do the needful. Another response is we can go back to any other place. Like that, humans can respond like anything. So we have to we are aware that how we can respond to a situation. That is what immediate actions, that is before, during, and after a disaster. And the last one is recovery. Recovery means it is after the disaster, we have to recover back. We have to bring everything back into normal. We have to bring our life back into normal. We have to bring our society back into normal. That is, again, a long-term process of restoring the affected communities. The buildings will be destroyed, our job and everything will be, our roads, our infrastructures, everything will be destroyed. We have to bring everything back to have a normal life after a disaster. So this is a disaster management cycle. So in this cycle, we will be handling, first one is mitigation, that is taking long-term actions to reduce the potential loss. Second one is preparedness, that is a process of getting ready to face the potential disaster. That third one, that is after disaster, we have to respond to it, that is an immediate action before, during, and after an event. And the final one is recovery, that is the long-term process of restoring the affected communities. So this is the phases of disaster management. We have like discussed about all the three things. That is, first one is mitigation phase. In the mitigation phase, what we can do is we can give public education and awareness. Mitigation phase is an early phase, that is before a disaster. That is, actually we have to give this public education and awareness to everyone regarding earthquakes, regarding tsunamis, or regarding any man-made disasters. Regarding any of the disasters, we have to give a public awareness. That public awareness may include the immediate first aid tricks and all, like how to like get out of that disaster management, like small disaster management ideas and all we can give in that public awareness or public education awareness part. Second one is hazard vulnerability and assessment. In this mitigation phase, if something is happening, we should be able to assess the vulnerability. We should be able to assess the situation. Then next one is what we can provide is improved infrastructure. That is what I have said. To a region where earthquake is very frequent, we have to build an infrastructure. We have to design an infrastructure such that it is like it is prone to, and we have to keep all the codes and everything, and we have to make this infrastructure earthquake resistant. So next one is the preparedness phase. In this preparedness phase, the national emergency telecommunication and response plans have to be like given to normal people. Training has to be given. Exercise, early warning, standard operating procedures, etc., has to be given to the normal people. In this preparedness phase, if something is happening, or if we are going to face something, they should be given training for how to handle the situation. People should be aware about the situation. We should, or the government or other agencies should give early warnings, and standard operating procedures should be taught to the normal people. Next one is response phase. In the response phase, communication and coordination for saving the life is very important, because if something is happening somewhere, actually what is happening is that that place will get like localized, that place will get detached from other people and other communication systems. So the one from outside that community or society will not be able to get and understand about an idea of what's actually happening over there. So communication and coordination should be there, and saving of life should be there. And the last one is recovery phase. In the recovery phase, we have to do all these things. First one is restoring telecommunication infrastructures. That is the very first thing we need after a disaster, because if people can communicate each other, they can send like what's happening here. They can communicate properly with the other people who is managing this disaster. Then improve lives and recovery, rehabilitation of other services, etc., have to be done in the recovery phase. So how does AI, IoT, and big data helps in managing disasters? So our topic is incorporating AI. AI is artificial intelligence, and IoT, that is Internet of Things, and big data in managing disasters. Nowadays, we are aware that we are like introducing AI in each and everything. Our mobile phones, our WhatsApp, everything is having meta AI. So if you have a doubt, we can just click on that. We can just ask AI, okay, what is this? What is that? So the AI will get us a detailed explanation about our doubt. So why can't we introduce AI, the Internet of Things and big data, in our disaster management? Okay, artificial intelligence, the Internet of Things, and big data are revolutionizing disaster management by enhancing prediction, optimizing response effort, and supporting post-disaster recovery. This integration enabled faster decision-making, saving life, and minimizing impact across all disaster phases. So this integration, or by integrating all these technologies into our disaster management, it will enable us to make our decisions faster. It will help us to save our life. It will help us to like minimize the impact across all disasters. It will give early warning about disasters. It can have like through satellites and it can have communication to a disaster area. It can help people to know what's happening there. It can help the medical team. It can help the fire force and rescue team. It can help the military or whatever team who is like acting into the disaster management. It can help everyone to get an idea of what's actually happening inside that disaster area or disaster area. So what is in disaster management, what is the role of Internet of Things or what is the role of IoT? In disaster management, the IoT will act as eyes and ears. It will act as a sense organ. It will see everything. It will hear everything. It will like see what's happening there, or it will hear what's happening there. And it will send these data to big data. And what is the role of big data? The big data will act as the memory. It will save all these data and it will send it to artificial intelligence. The artificial intelligence is a tool and it acts as a brain. So what the artificial intelligence does is, it will get the data from big data. It will see all the scenarios from big data and it will like tell us what we have to do. Or it will like simplify the situation and it will guide us to handle this disaster. So how does these three tools work together? How does IoT, big data, and artificial intelligence work together? So they are physical devices. In IoT, Internet of Things are physical devices, sensors or cameras, which gather real-time environmental data. So it can, they are cameras or they are physical devices, sensors or everything, which we can keep it somewhere and anywhere we need it, or any of the disaster-prone areas at all. And it will collect real-time, it will gather real-time environmental data like water level, like seismic activity, smoke, temperature, all these data, these sensors, these cameras will take, and it will send the result to big data. The big data, they manage and store the massive and diverse data collected from IoT. So the data collected by the IoT will be transferred to big data, and this big data will sort the massive and diverse data collected from IoT, again from IoT, then again from social media, from GIS, and it find patterns. It will see what actually happening is. Then this massive volume of structured and unstructured information, including satellite image, including social media feeds, including historic, that is previous records, that provide a comprehensive view of a situation. To study about a situation, if a flood happens, these tools, it will help. If a flood happens and a small village or something is underwater, we cannot see what's happening like beneath the water. We cannot like we cannot like locate the positions and go. Then the data collected from IoT can help us. It can say, okay, here there's a school, here there is a hospital, here there was a bridge, the road is like this, and all these data can be collected from IoT and big data. And what AI does is, it will process the layer that uses machine learning algorithm to analyze big data from IoT devices, identifying patterns and predicting disaster with high accuracy. These things will predict and it will deal disaster with high accuracy. How AI deal all these things? It will collect all the information from AI and big data. It will sort all these things. Big data will sort all these things and it will give to AI, and AI will find patterns. It will form algorithms to analyze the big data, the data from big data, and identify patterns and predicting disaster with, and it will predict disaster with higher accuracy. Or once a disaster happens, it will like lead us, it will lead the team, it will lead the medical team, or it can lead the disaster management team to act accordingly. So application in disaster management, that is the application of these tools in disaster management. First one is prediction and early warning. These tools can predict a disaster, can give early warning regarding a disaster. So AI analyzes sensors data to forecast events, that is seismic activity, hurricane paths, and triggers immediate alerts via smart devices. So when we talk about cyclones, all the cyclones, before a cyclones, we will be getting an alert. Nowadays, before a heavy rain, we will be getting a alert. We will be getting a message in our phone saying we will be having a heavy rain in another three hours, or like that. Or it will be like, say, all these areas are red alert area, this area is yellow alert area, like that. They will categorize the regions, or they will categorize the quantity of rainfall, and they will give an awareness through our smart devices or through our news channels and all. Next one is situational awareness. That is, drones and sensors provide live imagery and data, while AI interprets it to map damage and identify trapped individuals. That is, second application is situational awareness. If something happens, we can use drones and sensors to provide live imagery. It will show us actually what happening is there, and AI will interpret that live photo or live image from the previous photo, and it will help us to identify the intensity of damage, or identify the trapped people, trapped individual, and all. If maybe during a disaster, it is difficult for humans to reach into that part. Sometimes during earthquake and all, it is difficult for us to reach there and to save a life and all. So these drones and sensors we can use for that task. Next one is response coordination. The AI will also help to prioritize the rescue efforts. AI will tell the rescue team to which area you have to go first, and all these data will be provided by the AI. It will give the routes of emergency services efficiently, and it will manage logistics by analyzing needs versus available resources. Normally, what's happening is, if something happens, what we will do, all our rescue team, all our resources, everything will go into that disaster front area. Then we are not sure like how many people are there. Actually, what we have to do, no idea will be there. So some people will go this side, some people will go that side, the medical team will go this side. Like that, they will act. So this AI will help them to prioritize the rescue efforts. It will like manage logistics, and it by analyzing needs versus available resources. It will see what is available, and it will tell them where this resource is needed. Then the last one is damage assessment. AI processes satellites and drone image to quickly assess infrastructure damage, informing recovery plans. Okay, after a disaster, the AI processes the satellite images, and it will show us how much damage has occurred, or how we can plan a recovery, how we can plan for a recovery, and the AI will assist us. Next one is role of IoT, or role of Internet of Things. IoT provides the critical real-time data streams necessary for effectively management through a network of interconnected sensors and devices. The IoT, it will provide a critical real-time data streams necessary for effective management through a network of interconnected sensors and devices. Early warnings, IoT provide early warning systems, that is, strategically placed IoT sensors monitor environmental conditions like water levels. Okay, in case of dam and all, we will be getting, okay, the water level of the dam is getting increasing. In case of rivers and all, we will get that details. Okay, in the people who is residing nearby the banks of that particular river have to take care because the water level is increasing. Like that, we are getting data from IoT devices. Then seismic activity, if something is happening, some vibration is happening behind the earth, if something is happening behind the earth, our earthquake monitors alarm system and all, no, it will, we call it as Richter scale and all. It says, okay, there's something happening beside the earth, so you have to take care of it. Then the temperature, if the temperature is going up, we are getting like awareness of that. Then wind speed, that is the cyclones and all, we are getting awareness on all. And when these metrics reaches critical threshold, the sensors instantly transmit data to the central system, enabling the issuance of timely alerts of birth, earthquake, and wildfires. So what this early warning system does is, it will be all the time, it will be monitoring what is actually happening. And when the limit crosses the critical limits, when it crosses the critical limits, it will give data, it will transmit data to the central system. And from the central system, timely alerts regarding all this disaster will reaches common people. Then drones and smart cameras equipped with IoT capability provide live imagery and data from affected or high-risk areas, including those inaccessible to humans. These drones and smart cameras, we can use these equipments to get live image from the affected area, where the area those is inaccessible by humans. This enhances situational awareness for emergency responders, helping them to map damage and locate survivors. Again, the same thing. It will help the disaster management team to reach a location. It will tell them what is actually inside that. If somebody is trapped or something, these drones and these cameras, smart cameras, will give information about that to a nearby disaster management team. Then the IoT devices can even monitor the structural integrity of critical infrastructures like bridges and dams, identifying potential weakness before they lead to failure during a disaster. So these devices can monitor the structural integrity of critical infrastructures. We have like our monuments, we have our old buildings, and all those infrastructures we have. So we can use these technologies, these devices, to understand the structural stability of those buildings. So if something is happening, if the building is weak, these systems can let us know that the building is weak. So we can do necessary actions. We can take equations. We can, even if needed, we can do the retrofitting part, or we can leave that building, or we can demolish that building. So by doing all those things, or by taking necessary steps, we can handle, or we can handle a failure, or we can handle a disaster by using all these elements. In situations where traditional communication infrastructure fails, IoT-based mesh network can provide temporary connectivity, ensuring coordination among rescue teams and affected communities. That is our what is our traditional communication infrastructure? Our mobile phones, our internet, all these things are our traditional communication infrastructures. During a disaster, the first thing failed is all these infrastructures. Our communication will get lost. We will lose our electricity, our power, and everything will be gone. In that case, the IoT-based mesh network, that is a localized mesh network, we can provide this mesh network as a temporary connectivity, and it can help and it can coordinate the rescue teams and affected communities. So in that case, in the case of a disaster, the community, we can replace the communication through these IoT-based mesh network systems. And it will help our people, or help the disaster management team to get data from that particular place. Next one is role of big data. So initially we said IoT, what is IoT? They are ears and eyes. Now big data, what is big data? It is the memory. So big data refers to the collection and processing of vast volume of information from various sources, including IoT devices, social media, satellite imagery, and historical records. So the job of the big data is to collect volume of information. Its main job is to collect information wherever possible, from whichever sources. These big data will collect information. It can be from IoT devices, it can be from cameras, it can be from sensors, it can be from social media, it can be from our previous disaster records, or anywhere. These big data will collect and keep the information. The role of big data is it acts as a memory, right? It acts as a memory. So it will keep all the data within it. And next, the job is the data integration and management. A core challenge in disaster management is handling fragmented data. So during a disaster, somebody will be telling, okay, these things happen this side. Some others will be telling, okay, these things happen that side. Somebody else will be telling, okay, there is 2 or 3 people are stuck inside those big buildings. Somebody else is saying, okay, 3 people are there, 3 people are there. Like that, we will be getting a lot of fragmented data. And the core challenge is to handle this fragmented data. So what big data does is it acts as a platform, integrate diverse data sets into a unified logical format, providing a comprehensive picture of the situation. So this big data It will collect information from all the sources. It collect information from IoT devices like camera and sensors. It collect information from previous records like previous pictures and all. And it collect information from the social media post of somebody who is stuck inside. And it will like arrange all these things and it will give a comprehensive picture of what is actually happening. Then situational analysis, big data, also big data analytic process, massive data sets to identify affected area, gauge public settlement, track resource demands, and understand the dynamic nature of a disaster as it unfolds. So it helped in keeping all these things, and it helped in sorting out all the data collected from IoT and other devices. And again, it will give it to what? It will give it to AI. It will give all this data to artificial intelligence. So artificial intelligence is a last step from where we are getting all these data and we are getting all these ideas. And so what is the role of artificial intelligence? It acts as a brain. So it will decide what to do. Artificial intelligence will decide what to do. It will see all these data and all. It will check everything. It will get all the data and it will decide what to do. So AI transform the raw data collected by IoT into actionable insights and automate complex decision-making processes. So AI will give the final result, or it will give the final command like you have to do this, or these many people are trapped over there. So actually the situation is happening like this. We have all these buildings demolished. We have to get a medical team to this location. We have to get a surgical team to this location. Some of the people are safe there. They need food, and all this data, all these data, all these details, AI will like automatically they will make this decision and they will let us know what to do. So AI models are trained on historic and real-time data to predict the likelihood and severity of the future disaster. So AI models, they are also trained to understand the severity of a future disaster also. They will study, they will learn from the history of previous disasters, and it will keep us, it will predict the future, it will predict the severity of the future disasters also. Examples include AI optimized flood forecasting models that analyze rainfall patterns and river levels, and ML algorithm for predicting earthquake after shocks. So these methods, after a disaster also, it will give us information about what is actually happening there. It will optimize what's happening there. It will optimize the flood forecasting and all. Next one is AI algorithm. Analyze data on population density, infrastructure damage, and resource availability to determine the most effective route and prioritize area in need. This ensure an optimal use of limited resources such as medical supplies and rescue personnel. Then, using computer vision and deep learning, AI system can rapidly analyze drone and satellite images to assess the extent of damages, significantly reducing the time for post-disaster evaluation and recovery planning. Again, this AI will help us to significantly reduce the time for a post-disaster evaluation and recovery planning. After a disaster, if something happened at a society, something happened at a village or something, what we have to do is after disaster, we have to bring everything back into normal, right? We have to bring all the infrastructures, we have to bring hospitals, schools, we have to bring the houses and everything back into normal. So this AI, it will help us to evaluate the recovery planning. So what are the key benefits of introducing AI, IoT, and big data in disaster management? First one is mitigation and prevention. The first benefit of doing all these things is mitigation and prevention. That is vulnerability mapping. AI identifies structural weakness in critical infrastructures like dam, bridges, and power grid. That is one of the major benefits of introducing AI into our disaster management. These tools, these techniques, it can identify the weakness of our critical infrastructures. It can identify the problems of a dam. It can identify the weakness of the bridges and power grids, and it can give warning to us so that we can act accordingly. Second one is urban planning. Digital twin allow planners to stimulate disaster scenarios to design more resilient urban layouts. So whenever we are going to plan a city, whenever we are going to plan an urban area, We can take the data from these AI tools, and we can plan that cities or that society with keeping all these things in mind, with all previous disasters in mind. Next benefit is preparedness and early warning. So first one is high-speed forecasting. These AI models can generate medium-term weather and climate forecasts thousands of times faster than traditional physical-based models. These AI models can get medium-term weather and climate forecast. It can forecast rain, it can forecast wind, it can forecast winter, and all these things. All this climatic situation, whatever it is, it can forecast thousands of times faster than our traditional or physical forecasting method. How actually we are forecasting rain and all? We will study all the clouds and patterns of clouds and all, and we will predict rain and all. No? This AI can predict rain through the information which is collected from other devices, and it can give us early warning about the situations. Next one is hyperlocking alerts. Systems like Google, Android, earthquake alerts system use phone sensors to detect seismic activity and trigger alerts before the shaking reaches other areas. Okay, our Google, Android, and all those devices, all those sensors, no, it can easily sense these problems, these disasters beforehand, and it can alert us. Then early fire detection, AI-powered cameras and satellite imagery can identify smoke and hotspot often before they are reported to emergency services. That is, nowadays we have fire alarms in buildings, and we are installing fire alarms, and right. So smoke detectors, fire alarms, everything, all these things we are doing. So it can detect a smoke or something, and it can predict a disaster beforehand, and it can give awareness to the people. Then response. If something happened, the AI can help us in the response part, that is real-time situational awareness. Drones and robots equipped with computer vision scans disaster zones to locate survivors and assess damage in area too hazardous for human. In case of a gas leakage, in case of a chemical hazard, nobody can go inside and see what's happening. So in that case, in case of fire, or in case of an earthquake where all the buildings are demolished, we can send a camera, we can send a sensor, we can send a drone inside to see what's actually happening inside. Optimized logistics. Machine learning algorithm analyze road conditions and demand to prioritize the delivery of medical supplies, food, and water to the most critical areas. That is optimal logical logistics. In this case, it will a machine learning algorithm system analyze the conditions of the road, and it will give information to the medical supplies, food, and water, and it will lead them to the most critical areas. Next one is social media mining. NLP tools sit through millions of geological social posts to identify clusters of emergency messages and track the movement of displaced populations. That is, if whenever a disaster is happening, we will get an alert in our Facebook. You can flag a post over there that we are safe, and so that our relatives, our friends, and everyone can get an information about our situation. I don't know. So we can use all these systems, all these devices to get awareness about our situation to our friends and relatives. The last one is recovery. That is rapid damage assessment. AI automates the comparison of pre and post disaster satellite imageries, reduce damage assessment time from weeks to minutes or hours. That is, if a disaster happens, AI can get the post-disaster satellite images, and it can see the intensity of the disaster, and it can assess the amount, the quantity of damage happened to that particular location because of that disaster. Next one is psychological support. AI-powered chatbots provide immediate mental health screening and supports for survivors dealing with trauma or PTSDs. If somebody is trapped somewhere, if a disaster happened and somebody is trapped somewhere, their mind will go out of control. So the AI-powered chatbots, they can talk to the AI-powered chatbots, and they can provide immediate healthcare screening and support to the survivor. Next one is financial recovery. That is, automated system help track insurance claims and aid distribution to reduce fraud and ensure fund reaches the most vulnerable areas. Okay, when everything is for somebody, if everything is lost, they can use these AI powered systems to track their insurance, their claims, and everything, and it will help in reducing the fraud and other activities in this. So, what are the core operational advantages? First one is speed and accuracy. It processes things very fast, amounts of structured and unstructured data far faster than manual human analysis. If something happens, if we are going into a record room, we are taking out all the old records, we are seeing all the pages of that records, and we are finding out what actually happens. We are taking a master blueprint plan of that city, and we are seeing these areas are affected, and all these physical tasks will take time. So the AI, it will collect all the structured and unstructured data, and far faster it will deliver the results, and it will help in analyzing part. It will help in analyzing part. Second one is reduce human risk. Automates hazardous surveillance and reduce task protecting fire response, etc. For as I told before, when we are into a chemical disaster or something, these drones and cameras, we can send these drones and cameras to see what's happening inside. So it will reduce the risk of human going inside. Next one is resource efficiency. It minimizes waste by precisely predicting where and what resources will be needed based on the real-time impact data. So what resource efficiency is, it will collect the data and it will tell us, okay, where it is needed. So like that, it will ask us to provide whatever necessary. By this, we can reduce the wastage of resources what we have having. Then multilingual communication that automatically translates energy warnings and emergency warnings and relief instruction into various local languages to reach diverse population. If something is happening in local languages, this system will give emergency warning to all the local peoples over there. So I think I will conclude this topic a little early, because this is the last topic, and I know all you people are sitting in front of this for the past 1 week. So I will be concluding it a little earlier today. So to conclude, the AI or integration of artificial intelligence, the Internet of Things and big data has transformed disaster management from a reactive process into a proactive data-driven discipline. Beforehand, our disaster management was a reactive process. A reactive process means if something happens, we will react according to the situation. But when we are integrating this artificial intelligence, the Internet of Things and big data, it is now converted to a proactive data-driven discipline. That is, if something happens, we know what to do. Or this IoT or artificial AI will tell us what to do. We can ask the AI, okay, this situation has happened. Now I met with an accident, what I have to do? The AI will tell us what we have to do. AI will lead us. AI will hold our hands and will take us through the situation. So the IoT and AI, it will act as the sensing backbone, providing real-time data through millions of sensors. Big data processes these massive streams to find patterns, and AI serves as a decision-making brain, predicting hazards with up to 80 to 90%. Okay, so the IoT, it will act as a sensing background. It will give the data to big data, and it will process the massive streams and find patterns, and it will give these data to AI, and it will serve as a decision-making brain, predicting hazards up to 80 to 90% accuracy. Integrating IoT and AI systems have reported up to a 50% reduction in response time, significantly increases the chances of saving life during the critical golden hour of a crisis. So whenever a crisis occurs, there's a golden hour. We will get a little time. If we are responding, if we are reacting to that situation in this golden hour correctly, we can save about 50% of losses. We can save about 50% of life. We can save resources. So IoT system will help us to, will lead us to, will hold our hands during this reaction, during these golden critical hours. These technologies have fundamentally shifted the paradigm of reacting to a disaster to preventing its impact through advanced early warning system and real-time monitoring. These technologies will help us to prevent our disasters. These technologies will help us to prevent or help us to react during a disaster by giving early warning system, and it will also by having a early real-time monitoring system. So this is all about integrating AI. It is all about integrating IoT, and it's all about integrating big data into our disaster management. And I'm concluding this topic. Thank you.
Thank you, sir, for the insightful session. Now we move to the discussion section. I request the participants to kindly post their questions in the chat box, or you may raise your hand if you wish to ask your question directly. Please keep your question brief and relevant. So there is a question in the chat box. What role can digital twins play in stimulating disaster scenarios and planning?
Once again, I cannot like access this. Once again.
Sir, what role can digital twins play in stimulating disaster scenarios and planning? Sir, your mic is mute. Can you please unmute it? Sir, the mic mute aanlo.
Yes, something happened to this.
Okay, sir, can you see the question in the chat box? Should I read it?
One second. Hello.
Hello, sir.
Can you hear me?
Yes, sir.
Yeah, can you read that question for me?
Yes. What role can digital twins play in stimulating disaster scenarios and planning?
What role? Okay, digital twins. Okay. Okay, I think we can create a virtual replace of systems using real-time data stimulus. Okay, we are getting all the data from IoT and all, no? So we can create a virtual replicas of the cities or systems, and it can give a correct stimulate about the. It can give a correct idea about the scenarios like earthquakes and all. Hello.
If there is any more question, please put that in chat box or raise your hands.
Something happened.
So can you hear me?
Yeah, tell me. I cannot see the screen. That's a problem.
Okay, there is one more question. Can machine learning models be practically validated and trusted for life safety critical decisions in disaster management?
Can machine learning?
Models can be practically validated and trusted for life safety critical decisions in disaster management.
Machine learning models.
Okay. Yes, sir.
I will just go through it a little. I'm not sure about it. I will give the answer in the chat box before I conclude the session.
Okay, sir.
Anything else?
Is there any more questions?
Okay, then thank you. I will answer for this question. Okay.
Okay, sir.
Hello.
Sir,
Yeah, thank you.
okay.
Thanks a lot for
Okay. Thank you, sir,
listening to me
for
for the last 1 hour. Thank you. Thanks a lot.
thank you all for participants for active interaction. And once again, thank you, sir. You may leave the session. Okay, now I request Miss Asha Devasikutti ma'am, Assistant Professor of Civil Engineering Department, IS College of Engineering, for take over the session for the feedback. The feedback link of session 3 will be uploaded in chat box and also in WhatsApp group. Please fill it.
Dear participants, the last session is now complete. The next session is the feedback session. In the session, our esteemed faculty members will be provide their feedback of our FTP. Let me introduce our faculty members who will be sharing their feedback. Dr. V. Lilitha, Assistant Professor, Department of Commerce and Management, SRC, University. Then next one is Shiva Hamin Sai, Assistant Manager, Civil Engineer. Then next one is Dr. Suhail, Assistant Professor, Department of Civil Engineering, Kashmir College of Engineering and Technology, Srinagar. And next one is Kaiser Salim, Assistant Professor. So we now invite our first faculty member, Dr. V. Lilitha, to share their feedback about our FTP.
Thank you, madam. Thank you very much. Good evening to one and all. I'm very honored to to share my feedback. I am assistant professor in SRC Sastra University. It is located in Kumbakonam, and I belong to Commerce Department. Basically, I am handling accounts, commerce, human resource management. But I am very much interested in disaster management. That is why I have chosen this topic. The reason behind my selection is my native is Nagapattinam, where I completed my schoolings, and Nagapattinam was severely affected every year by cyclone. Okay, it is a cyclone-prone coastal region, and residents receive annual warnings related to cyclone activity. In those days, there was no IoT, WhatsApp, chat GPT, etc., etc. No technological equipments, tools were there. So they announced publicly with the help of cycle rickshaw they used, and they announced they warned people, but people didn't care much about the cyclone because every year they warned the people. But when I was studying 6th standard, we had a severe cyclone. Many people lost their houses, and they were staying at temples, schools. My school was closed for 1 month, for about 1 month. After that, we had shift system. Many normal lifestyles or were affected, and after that, that incident affected me a lot. Even though I was in a safer side, I was in a concrete house. Many huts were affected. Many people lost their houses, and they were distributed food packets with the help of the helicopter and all. So that disturbed me mentally. I am disturbed till now. Then after that, again, the Nagapattinam, same Nagapattinam, was affected by tsunami. So that time I was not there. I was working in Sita Lakshmi Ramaswamy College. So later on I came to understand that many of the children who were residing near the coastal, that is sea, they lost their life. And many times I visited that area for NSS purpose. So I felt very sad, and I do not know. I am helpless because I do not know disaster management and all, and I'm very much interested to know about it. Even though the government took a lot of actions, I'm not blaming the government. the government took a lot of activities, preventive measures have not done because they were not aware of the tsunami. And that was the first time Nagapattinam was hit by tsunami. And so after the celebration of the Christmas, they lost their life. Many elders and many children, see, when they carried, they showed it in the TV, and when they carried the babies, I was crying like anything. Because it is my native. So that scene affected me psychologically very well. That is why I have taken this topic, even though I belong to the commerce department, the management department, and I congratulate the team members as well as the experts. They explained the concept very well. Technical things, to be very frank, I don't understand, but general thing, water, brown water, then gray water, and all very interesting. And one sort of cement, special cement, concrete, explained well, and water management, flood management, and minerals. So even though I couldn't understand certain things, I attended the sessions very enthusiastically, and I learned something. So Nagapattinam is the main reason to select this topic. And nowadays, with the help of all these things which you have explained, all the experts explained well. They took their effort level best. They explained, and many questions were asked by the participants. I didn't ask any question because I don't know completely know. And so, but I have absorbed. I'm highly satisfied with this FDP and team members. Whenever I feel some disturbance, connectivity, internet connectivity, or doubts, I approach them. They responded very quickly in a very friendly tone. That should be appreciable. And hats off to all of them. Thank you very much. Thank you for giving me this opportunity to share my feedback. Once again, thank you all.
Thank you, ma'am, for giving your valuable insight. Next, we invite Shiva, Hemant, Sai to share their feedback.
Very good evening to everyone. After having a wonderful session, today 3 sessions, and overall 6 days of Atal FTP on disaster management and resilience infrastructure. So after the FDP is completed, I can show that the learning outcome for every individual is highly appreciable. So in this FDP, we have learned about resilient infrastructure, which is having compatibility with AI, IoT, and other software-related things also in disaster management. Apart from this, special concretes have been clubbed with disaster management. That is highly appreciable. And at the outset, I thank everyone.
Sir, is there any connectivity problem?
Sir, your voice is not audible. Are you there? Sir?
I think he has some connectivity problem.
Connectivity issues, internet issues. You move on
So
to
you
next
want
person.
to us? Yes, yes. Thank you, sir, for giving your valuable insights. Next, I invite Dr. Suhail Aijaz Shah.
Respected Chief Guest, Honorable Principal, HOD Department of Civil Engineering, respected resource persons, and all, especially to the organizing community, program coordinators, and esteemed colleagues and faculty members that have joined this session. Good evening to all the participants and all the attendees of this FDP program. It has been my immense pleasure that I have been honored to be the part of this session, ADP, FDP program, disaster management and resilient infrastructure that is being organized in a proper manner by IES College of Engineering under the agencies of AICT Atal Academy. At the onset, I would like to extend my congratulations to the organizing institution for conceptualizing and successfully conducting this highly relevant FDP and trusted program, especially enriching the field of civil engineering. As it is said, when educators are empowered with knowledge on disaster resilience, they become the architects of safer infrastructure and a catalyst for sustainable development. In an era of this modern time where the increasing frequency and intensity of natural and man-made disasters is tremendously increasing, the theme of this program could not have been more than timely and significantly presented, as has been presented in a very fruitful way all these 6 days. Over the past 6 days, this FDP has offered an exceptional opportunities in interacting with enriched academicians, professionals, and expertise in the field. The series commensally covered the disaster management spectrum from fundamental concept to the international fundamentals, frameworks, advanced applications of the GIS, remote sensing, AI in the field, IoT, and the big data, the last session that concluded today, the disaster management session. The discussion on the earthquake resilient infrastructure, retrofitting, urban planning, zoning, green infrastructure, climate adaptations, the warning system, all involve the community engagements that have truly strengthened our collective understanding, I think, over this resilient infrastructure development. It is said the true value of the expertise lie not in the knowledge alone, but in the wisdom generally shared to inspire, guide, and empower the future generation. I would like to place on record my sincere appreciation to the distinguished panels from the expert from premium institutions such as NIT Calcutta, NIT Pondicherry, some international universities, reputed architectural schools, industry leaderships. They all scholarly contributed to the different case studies from their field and had insightful over these sessions that made us understand the gap that is bridging between the industry and the policymakers. This FDB is not merely a knowledge of sharing the experience. It is a platform for reflecting collaboration and capacity building programs. It reinforces the crucial role of faculty members and the knowledge as a knowledge multipliers. It is now the duty of us, all the teachers, all the faculty members, what we have taken here has to be shared towards students. I will be sincerely commending the IES Engineering College for its commitment to the academic excellence and the professional development that has been showcased in these 6 days. With the state of art of infrastructures, student governance, good governance, visionary leadership, and under the able guidance of Principal Dr. S. Barley, supported by dedicated teams of faculty members, head of departments, and associated members, this center is surely going to be a center of quality education, aligning with the national priorities. The efforts surely of the program coordinator and the organizing community, along with the technical support team in making this FDP has been resounding its soundness success. As we conclude this program, I urge all the participants to translate these insightful sessions according to Indian curriculum, interdisciplinary research, policy advances, and in the infrastructure practices. I once again congratulate all the participants for successfully complementing and contributing in the success of this FDP program. The organizers have pivoted their role in a very beautiful manner, taking to the softer corners, moving towards the end of this session in which all connected to each other remotely and enjoyed these moments in a very fruitful manner. मुसाफिर है हम भी, मुसाफिर है तुम भी, किसी मोड़ पर फिर मुलाकात होगी. As we draw the conclusion of this FDP on this thoughtful stand, I would like to leave this with a beautiful words. कहीं नहीं मुलाकात का खत मिला, तारीफ है तो मुलाकात फिर कहीं होगी. It means I would like to extend my gratitude towards the institution and hope in future whenever such events are organized, we will try to shift from the online mode to the offline mode and interact in a fruitful and a very good manners. With these words, I will wish institution continues its success and look forward for many fruitful sessions. Thank you to all. Shubh Ratri, Shabba Khair.
Thank you, Dr. Suhail Aljaz Shah, for your valuable insight about our FTP. Finally, I invite Kaiser Salim to share their feedback about our FTP.
Respected coordinator, honorable resource persons, and dear participants, good evening to everyone. Myself, Kaiser Salim, working as an assistant professor at AGC Amritsar. I am happy to share my feedback on ABDP titled Disaster Management and Resilient Infrastructure. This ABDP was very useful and meaningful for me. It helped me understand different types of disasters and why disaster preparedness and resilient infrastructure are so important today. The sessions explained how proper planning and design can reduce damage and save lives. This program was special for me because I belong to Jammu and Kashmir, a place that often face floods, landslides, and earthquake risks. While attending the sessions, I could easily connect the topics with the real problems faced in my own region. It helped me see how better engineering and planning can make our towns and cities safer. The FDP also showed the disaster management is not only about buildings and structures, it also involves good urban planning, use of modern technology, and participation of the community. The examples and the case studies made the concepts simple and practical. As a faculty, this FDP has inspired me to include disaster management topics in my class and guide students to think about safety, sustainability, resilience while designing structures. I sincerely thank the organizers, coordinators, and all the resource persons for organizing such a well-planned and valuable program. This FDP has improved my knowledge and will help me in my teaching and professional work. Thank you so much, everyone over here, and have a great day. Thank you.
I am inviting from the faculty say if anyone is willing to share their feedback, please. 127 faculty members are there. So we are expecting some more feedback from your side.
Respected the management of the IES College of Engineering, Department of Civil Engineering, IES College. Just now I have given my feedback, and I think due to network issue, it was not given fully. So that is the reason I'm telling again feedback. So firstly, I would like to thank the organizers for organizing this FDP in an efficient manner, taking their valuable time, and also thank all the participants, including me, for sparing their valuable time from every day, right from 6 p.m. to 9 p.m. And it was like a good timetable, and all the lectures were properly organized. I had a great opportunity to interact with Priya S. Nair madam in this FDP, which is more helpful for me in my research area. And other faculty members who are from foreign and also from NITs and IITs. Really, the crew was very good, and all the sessions were overwhelming, and which are helpful in disaster management, and the presentations were published very good, which will be helpful for us to tell to our students when there is a disaster happening in any place. Even I am from Hyderabad, and recent floods in Hyderabad are also due to Musi River improper organization of anything, whatever you say. So that will be helpful in our area also, how to manage the disaster when it happens, and also the prediction models using AI and IoT. So all these are very helpful for the present budding faculty, and also as per the change in our society, one must learn irrespective of the age of any teacher or professor or any other stream where we are learning or studying or whatever we are teaching. We have to learn AI, ML, and IoT, cyber security, and everything. We have to be aware of it, not only for the book knowledge. And these type of FDPs will surely enhance the faculty mainly, and also the appropriate profession. So thank you everyone. Thank you, ma'am, for organizing this lecture, HOD and other faculties. Thank you very much.
Thank you, sir, for giving your insightful feedback.
Madam,
Yes, sir.
yeah, I'm Dr. J.T. Naidu from Visakhapatnam, Dr. Lankapalli Bollai College of Engineering.
Okay, thanks, sir. You can give your feedback.
Yeah, I want to give the feedback. Last month only we conducted one FDP, Atal FDP. And this FDP 6-day faculty development program was highly informative and well organized. The sessions were relevant, structured, and aligned with the current academic and industrial requirements. Resource persons demonstrated a strong subject expertise and explained concepts clearly with practical examples. The program enhanced the participants' knowledge, teaching methodologies, and research orientation. Interactive sessions and discussions encouraged active participation and knowledge sharing. Overall, the FDP was beneficial and contributed significantly to all our professional development. I thank the org principal and the department for conducting this type of program. ES College is very well structured program they conducted. Thank you very much for giving this opportunity.
Thank you, sir, for giving your valuable feedback about our FDP. If anybody else wish to give their feedback about our FTP, you are most welcome to do so. Okay, then dear participants, the examination link will open at 6:30 p.m. immediately after this session. Please ensure your internet connectivity is stable. If you face any difficulties during the examination, you can contact us at any time. Let's get ready to start. Let's get. Sorry, sir. Do you have any concern? Okay, let's get ready to start the examination at 6:30 p.m. All the very best to everyone, and our valedictory function will be start by 7:30. Thank you all. Sound. A very good evening to all. Respected Principal, esteemed Head of Departments, Honorable Faculty Members, distinguished resource persons, dear participants, and my dear colleagues. It gives me immense pleasure to welcome you all to the valedictory function of AICT Training and Learning Academy sponsored faculty development program on disaster management and resilient infrastructure, organized by Department of Civil Engineering, IESC College of Engineering, Chittilapalli, held from 15th to 20th December 2025. I am Asha Devasikuti, Assistant Professor, Department of Civil Engineering, and I will be the host for today's valedictory function. Silent prayer. To begin this auspicious occasion, let us pray for a moment. May the knowledge gained during this FTP inspire us to contribute meaningful towards disaster preparedness and resilient infrastructure for a safer and sustainable future. Thank you. Welcome note. A warm welcome sets the tone for any meaningful gathering. I now invite Ms. Bhima B.V. Jalil, Assistant Professor, Department of Civil Engineering, to deliver the welcome address and formal welcome the gathering.
Am I audible?
Yes, ma'am, you can.
Respected Principal of IES College of Engineering, Dr. S. Brilli Sangeeta ma'am, our Head of Department, Ms. Anju EM, my dear colleagues, and most importantly, our dedicated participants from across the country. A very warm and pleasant evening to all of you. As we reach the conclusion of this intensive 6-day journey, It is my absolute honor to welcome you to the valedictory function of AICT Training and Learning Academy-sponsored Faculty Development Program on Disaster Management and Resilient Infrastructure. Over the past week, from December 15th until today, we have engaged in deep academic discourse, explored innovative technologies, and shared insights on building a more resilient future. This program, hosted by the Department of Civil Engineering at IES College of Engineering, has been a testament to our collective commitment to professional growth and social responsibility. I would like to extend a special and respectful welcome to our principal, Dr. S. Brilli Sangeeta, who constantly makes us such academic interviews possible even in her absence. I also welcome our HOD, Ms. Anju EM, who has been the guiding force behind the successful execution of this FDP. Finally, I welcome each of you, our participants. Your active engagement in these evening sessions has truly brought this program to life. Once again, a hearty welcome to all of you to this closing ceremony. Thank you.
Thank you, ma'am, for the gracious welcome. Summary of FTP. Over the past 6 days, this FTP has provided an enriching platform through expert lectures, interactive sessions, and knowledge sharing on various aspects of disaster management and resilient infrastructure. To present a concise overview of this academic journey, I invite Ms. Anju EM, Head of Department Civil Engineering, to deliver the summary of the FTP.
A warm greeting to all. As you know, we are together for this past 6 days. We are together and we are moving together from 6 to 9:30, nearly 9:30. We all are joined together for to grab such certain knowledge. There was a lot of topic while we are coming to FDP application. There are a lot of topics came, but from that we selected this disaster management and resilient infrastructure. As civil engineers, we were concerned about the structural stability and all. So during the construction time itself, we have to identify and we have to focus on the resilient structures. That's why we choose this topic. The thing is like that, we hope we can convey the basic things and knowledge to everyone, not only to the core branches of civil, other than that, every branch of people, how we convey the things. Through this 6 day, we came to deal with 9 guests and we come across nearly 13 sessions. As today is the end of this session, nearly 330 participants were registered for this session. In the WhatsApp link itself, group itself, you can see 320 plus participants, but the average participant rate was 145 and the maximum is 200. While dealing 13 sessions, we can maintain in 145 count. That is also, we are thinking it's a great success. I think in the group itself, now we are getting a lot of comments and queries. Hope after this session, before the end of this day, we can rectify most of the comments. If anything is also pending, we will look after in next days. I think up to this moment, you got enough output from our end as coordinators, because we are now with a lot of team members. We were there. If any future also, if you have any doubt regarding say FDP and a clarification in the Atal portal and all, we will be there with you. So I thank God to give this opportunity to organize this FTP. That all about this FTP. In future also, while in future, from today onwards, you may think about the resilient infrastructure, sustainability, everything. It may lead to think about the sustainable future. So hope all the best for everyone.
Thank you, ma'am. Next, actually, is a message from our principal. Due to some inconvenience, she is not present here. Next, feedback. Next is a vote of thanks. As we approach the conclusion of today's program, it is time to acknowledge and thank everyone who contributed to the success of this FTP. I now invite Ms. Steffi Maria Simon, Assistant Professor, Department of Civil Engineering, to propose the vote of thanks.
On behalf of the organizing committee and the Department of Civil Engineering, I am honored to extend a formal vote of thanks as we conclude our 6-day online faculty development program on disaster management and resilient infrastructure. We express our sincere and heartfelt gratitude to the AICT Training and Learning Academy for sponsoring and extending continuous support for this online faculty development program. I wish to express my deepest gratitude to the IES Education Society Management for granting us the opportunity to host this program. Your vision for academic excellence and constant encouragement provided the foundation for this event. We are profoundly grateful to our principal of IES College of Engineering, Dr. Brilli S. Sangeeta, for her constant encouragement and belief in the professional growth of our faculty. Your continued guidance and unwavering support in making this crucial program a reality. We sincerely grateful to our guest speakers, Dr. Ajish S.S., Ms. Anu V.V., Dr. M. Sumesh, Dr. Reshma T. Wilson, Dr. Nidhi M., Mr. Ajisen K. Shaji, Ms. Anu Paul, Mr. Samuel Idikula, Dr. Blessin, Dr. Naveen Joseph, for joining us from their respective locations. Despite the digital distance, your expertise, thought-provoking sessions, and willingness to share your professional insights have immensely enriched our knowledge. Our sincere appreciation goes to the program coordinator, Ms. Anju E.M., HOD of the Civil Engineering Department, co-coordinators, and the organizing committee members for their dedicated efforts, meticulous planning, and effective coordination throughout the program. I acknowledge the invaluable support of the technical team, Mr. Martin P.R., Mr. Sanal K., and Mr. Ashwin K.R., whose prompt assistance ensured smooth conduct of the online session without any interruptions. And I'm also extending my thanks to our administrative officer, Ms. Sajida Babu, for timely support and cooperation. Finally, we extend our heartfelt thanks to all the participants from various institutions for their enthusiastic participation, active interaction, and thoughtful engagement during the sessions. Their eagerness to learn and share ideas truly enriched the program and made it a collaborative and rewarding experience. Also, special mention goes to the participants who have expressed their sincere feedback about our FTP. Once again, we express our sincere thanks to everyone who contributed to the success of this online faculty development program, making it a meaningful, enriching, and memorable learning journey. Thank you.
Thank you, ma'am, for that heartfelt vote of thanks. Next, closing. With this, we've come to the end of validity function of AICT Atal sponsored FTP on disaster management and resilient infrastructure. On behalf of IES College of Engineering, I sincerely thank all the dignitaries, resource persons, participants, coordinators, and organizing committee members for making this program a grand success. As we celebrate this festive season, we extend our warm and heartfelt wishes to everyone present. Wishing you all a very happy Christmas and a happy New Year. May the coming year bring peace, good health, success, and many new opportunities to all of you. Thank you all for your presence and cooperation. Have a pleasant night. Thank you all.